louder would be better.
Hello.
Yes.
Yeah.
Now it's okay.
No,
Should I?
start at 10. Sharp
Okay, sir.
10.
Okay, sir.
Loveleen, I think we can start.
Okay,
Yeah.
sir. A very warm good morning to everyone. It is a great honor for me to welcome all of you to the webinar on the occasion of International Day of Clean Air for Blue Skies, organized by Center of Excellence for Research on Clean Air, Indian Institute of Technology, Delhi. On the behalf of the entire CERCA team, I would like to express my sincere gratitude for your virtual presence in this webinar. Before I introduce our first speaker, I would like to announce few housekeeping rules for the entire webinar. First, this session is being recorded, and by attending this webinar, you are consenting to be recorded. Please rename yourself with your name and the name of your organization. If you have a question, please use the Q&A box on the bottom right of the screen. Please ensure you join via device audio and your device volume is properly adjusted in case you are unable to hear rules for the entire webinar. Now, I would like to invite Shri Arun Duggal, founder of CERCA IIT Delhi, to deliver the opening remarks.
Thank you, Loveleen. Good morning, ladies and gentlemen. I hope all of you and your families are healthy and safe under these very challenging circumstances that all of us are going through. I'm very happy to join you on this very important day, International Day of Clean Air for Blue Skies. Over the last 100 years, particularly in the last 50 years, India and world has witnessed tremendous progress. There has been progress on people's health and education, mobility, availability of motorcycles, cars, air travel, availability of information and entertainment through radio first, and then television, and then mobile phones, and now internet. And material things like fashion, cosmetics, luxury items, etc. There has been a widespread availability. However, all this development has come about at a tremendous cost to the environment. The approach by governments until the last decade has been develop first and then clean up later. Now, a much more sensible approach of clean development is being pursued by the government in India and most other governments. It will be pertinent to remember what Mahatma Gandhi said 100 years ago in the early 1920s. He said, "The earth, the air, the land, and the water are not an inheritance from our forefathers, but a loan from our children and coming generations. We have to hand this over to them at least as well as it was handed over to us. So even 100 years ago, a thinker like Mahatma Gandhi was concerned about environment and clean air. While the environmental and air pollution challenges are huge and daunting, I'm convinced that through concerted effort, we can make substantial progress over time. Let me give you an example which gives me confidence. About 20 years ago, I was based in Japan, in Tokyo, and my office was in a high-rise building on 34th floor. From my office or from Tokyo, Mount Fuji, which all of you must be familiar with, was not visible, except when it rained, after the rain stopped, at the horizon, we could see Mount Fuji very clearly, the snow-capped Mount Fuji. You must have seen the pictures. However, as the time passed, gradually it became hazier and hazier and hazier, so that after several hours, maybe a day, it was just not visible. So it was clear that what was happening was that the air pollution levels were gradually rising, which were making Mount Fuji, not visible from Tokyo. However, when I went to Japan about 5 years ago, due to a number of measures taken by the Japanese government in terms of fuel quality improvement, emission standards of cars, emission standards of industries around that area. Now Mount Fuji is visible most of the days. So that gives me a confidence that we can also aspire to have clean air and blue skies in India also. We started Center for Clean Air, a Center of Excellence for Clean Air at IIT Delhi in 2018. And a number of very important research projects and initiatives have been taken. Mr. Hemant Kaushal will brief you about them in a few minutes' time. Our sights are set now to do further expansion and growth of this center, or this center to be the core to set up at IIT Delhi, potentially a school for environmental sciences, which will cover not only clean air, it will also cover climate change, water, effluents, waste, health impact of air pollution, and many areas where researchers can collaborate and join and add to the scientific knowledge, but also work with the policymakers to provide them with research as well as feedback on some of the policies which are being enacted. The center will also aspire to collaborate with the industry to provide technologies for improving the affluents and emissions from industry and helping the industry to reduce their carbon footprint. So this is our ambition. We have a big agenda for the next year too in this area, and I'm delighted that we have partners like all of you to help work with us jointly to take this agenda forward. Once again, I'm delighted to be part of this seminar, and I thank you very much for joining us.
Thank you, sir, for the words of wisdom. Now, I would like to invite Shri Hemant Kaushal, Project Coordinator, CERCA IIT Delhi, to kindly present the glimpse of CERCA activities.
Hemant, you are on mute.
Hemant sir, you're on mute, sir.
Thank you, Loveleen, and thank you, Arun sir, for your inspiring speech. That gives us a lot of adrenaline to, organize this webinar for the first time. I am really thankful to all the esteemed panelists, the speakers and invitees for having accepted CERCA's invitation to join this webinar to celebrate the September 7th as the International Day of Clean Air for Blue Skies for the first time. I remember when Professor Sagnek returned from South Korea from a conference in 2019 and informed that such an occasion is in the making. And now it has really turned out to be really true. The United Nations General Assembly adopted the resolution to hold an International Day of Clean Air for Blue Skies on September 7th every year during its 74th session held in December 2019. The day aims to raise public awareness at all levels, be it individual, community, corporate, and government, and to promote and facilitate actions to improve air quality, which is important for health, productivity, economy, and the environment. The first celebration will set a precedent for an important and exciting new International Day for Clean Air to be celebrated annually. CERCA feels honored to host this event. Ladies and gentlemen, I'm pleased to now take you through a brief tour of CERCA and its activities that were carried out during the year 2019. So I'll be sharing my screen for a brief presentation on the activities of CERCA in 2019. Can you see the presentation?
Yes, sir.
Okay.
So could we please put it on full screen mode?
Yeah, just hold. Okay. Well, CERCA was founded with the help of Mr. Arun Dugal, whom we just heard, who is an ex-alumnus of IIT Delhi and a very well-known name in the Indian and international banking and financial industry, having previously worked as the CEO of Bank of America in India and a former chairman of Shriram Capital. He currently serves as chairman on the boards of several companies in India and abroad. We are truly grateful to our founder. CERCA was officially inaugurated by the Honorable Lieutenant Governor of Delhi, Shri Anil Bajal, in February 2018. The approach of CERCA. The CERCA's approach is to combine the best practices from the entire ecosystem, which includes multidisciplinary research projects providing scientific information to policymakers, feedback on effectiveness of various air pollution management programs, help enhance public understanding and participation in promoting clean air initiatives, collaborate with industry on clean air equipment and emission reduction initiatives, as well as indoor air quality improvement. CERCA to take up projects on climate change with effect from 2020. We have expanded our scope of activities and broadened our vision to include projects on climate change starting 2020. The major activities that CERCA carried out. We undertook a couple of important research projects on air pollution. The first one was monitoring air pollution impacting Delhi NCR using a hybrid approach. A detailed report on stubble burning was prepared by identifying some 500 villages in Punjab and Haryana that had the maximum contribution to stubble burning. Work on the second objective of the project was to identify changes in the open burning pattern, pollution at large point sources like thermal power plants and brick kilns, for which the work is going on. 2 policy papers were published on the requirements of a robust and hybrid monitoring system in India for successful implementation of the National Clean Air Plan. The second project that we undertook was assessment and prediction of air quality using dynamically downscaled high-resolution data from the numerical models. Under this project, assessment of stubble burning impacts on PM2.5 concentrations were carried out during the 2 episodes of stubble burning in Punjab and Haryana from in October 2019 and November 2019. Further, assessment of power plants' impact on air quality was also undertaken in Delhi NCR region using the WRF CAM model with numerical simulations. The analysis is currently in progress. The third project was a select study of air pollution reduction programs around the world, governance and implementation. A working paper was prepared on governance and policy framework for air pollution control strategies and key recommendations on strengthening the existing clean air legislations, encourage public awareness and actively participate, and with good governance and integration of clean air objectives into the economic goals. The report also covers the best practices that are followed across different countries, especially Japan. The third project that we undertook was a pilot deployment study of particulate matter sensors in Delhi's buses. Now, this work involves instrumenting the vehicle fleets of Delhi's integrated multimodal transit system with sensors that travel across the city to measure particulate matter and scale up the spatial coverage of the sensors. In addition, the vehicle-mounted instruments would have other sensors, computation and communication facilities so that policy questions, they become more tractable. The proposed instruments would have low-cost PM sensors accurately calibrated against the BAM, and the work of installation in Delhi's bus fleets would be resumed after the lockdown period. It is still on hold because of the lockdown situation, and it will be resumed after it is over. Then CERCA also undertook a baseline survey on the indoor air quality in Delhi. So in partnership with the Society for Indoor Environment, CERCA undertook this study in various buildings in the national capital, including colonies, offices, hospitals, cinemas, restaurants, and metro. And the findings would be released to the public through a media event, which we are planning to hold around October and November. Another important project that CERCA has sponsored is basically a startup we have sponsored in IIT Delhi on studying e-rickshaw operations, where the main idea is to develop a network of charging and parking infrastructure for rickshaws, e-rickshaws, so that they can continue with their trips without being stopped by drained battery issues. E-rickshaw drivers generally face a problem as they charge their vehicles in home or from shops by paying high tariffs. Due to such hindrances, they are forced to make much fewer trips, as taking the vehicle back to home for charging is not always feasible in terms of distance and time spent in charging. Due to the unavailability of parking spaces, e-rickshaws pick up passengers from locations which are not suitable also. This causes uncontrolled congestion and lack of passenger safety. So designing an optimal parking location infrastructure with people on board and deboard vehicles at some designated places, leading to increased safety and decreased congestion on roads. Lastly, we also have undertaken and sponsored another startup which is working on the modeling of reverse logistic networks for consumed electric vehicle batteries. As you know, many countries, including India, around the world have established a rule for environmental conservation on the companies which produce electric vehicles. Now, according to it, the disposal of the car batteries is the responsibility of the company producing it. Now, this challenge of collecting the batteries from the public takes up an entirely new magnitude in a country like India. The project aims to develop a reverse supply chain model to help the electric vehicle industry to set firm foot in India. And in the second part of this project, an attempt would be made to design and launch a mobile application which would aid the customer and company to undertake the exchange of batteries. CERCA also undertook a lot of best practice learning initiatives, through a host of initiatives that we undertook during the year 2019. The first one was the Tsinghua University Summer School Program. As a step forward to learn from international experience, CERCA nominated 5 undergraduate students of IIT Delhi to the School of Environment at Tsinghua in China to attend the 2019 Tsinghua International Summer School. And during their 2-week stay at Tsinghua, the students learned about various environmental issues in China and the initiatives taken by the government to resolve these issues. A knowledge exchange session was held in partnership with the US Embassy, in which the CEO of Bay Area Air Quality Management District, San Francisco, California, was invited to deliver a lecture on the best practices on air quality management and an overall approach to protect and improve public health, air quality, and global climate, including air quality monitoring, regulations, control measures, innovative strategies adopted by the Bay Area Air Quality District for ambient air monitoring in that area. Another workshop that CERCA organized was on Blue Sky Initiatives for Delhi, which was in partnership with the Embassy of Japan and a couple of other agencies like the Japan International Cooperation Agency, Clean Air Asia, and the workshop mainly focused on clean air strategies and initiatives taken by the government of Japan. A roundtable on air quality was organized in partnership with the US Embassy, which was attended by the Ambassador Marcia Bernicat, who is currently the Principal Deputy Assistant Secretary in the Bureau of Oceans and International Environmental and Scientific Affairs at the US Department of State, who shared her government's perspective on air quality and how it is linked to climate action and the need for data gathering, raising awareness, and the role of democracy and law to resolve the issues related to air quality and climate change. We had the honor of hosting a media delegation from the Swedish television who visited CERCA and presented the Swedish experience in combating air pollution. Another conference was organized on stubble burning, findings, ground issues, and policy perspectives, basically to help the government in prioritizing actions in stubble burning, especially the policy and resource prioritization. The workshop also covered important topics such as the association between stubble burning and cardiovascular health, alternatives to crop residue burning in India, ground issues, gaps and remedies, crop residue management, and tracking from space for prioritizing mitigation strategies, use of models to study the effect of stubble burning on PM2.5 concentrations, artificial intelligence-enabled platforms to monitor and regular farm fires in India, and perspectives from Delhi IIT startups to solve the problem of crop burning. Another workshop that CERCA organized was the path to clean air, reducing fine PM concentrations in partnership with the US Embassy. A unique feature of this workshop was a sharing of the US success story in tackling air pollution by the US Science Envoy, Dr. James Shore, who's also a professor of civil and environmental engineering at the University of Wisconsin-Madison, who's got extensive experience in source apportionment and whose work focuses on developing a quantitative understanding of the origin of air pollution. Air Quality Roundtable was organized with Mr. Shin Bonkil, who's the current ambassador of the Embassy of the Republic of Korea in India. The roundtable highlighted the Korean experience of grappling with air pollution and the significant progress made by the Korean government in this direction through very focused, extraordinary efforts, particularly in policy making, passing of legislations, and leveraging of powers. We also had the honor of hosting a delegation from the University of Helsinki, Tampere in Finland, basically to discuss matters of mutual interest and especially joint collaboration for development of low-cost air quality monitors. Another delegation that visited CERCA was from the University of Washington, Professor Pratim Biswas, who's Lucy and Stanley Laporta Professor of Environmental Engineering Science and the Assistant Vice Chancellor for International Programs from the University of Washington, visited CERCA to discuss joint projects, training programs, and setting up of air quality sensor calibration lab at the IIT. CERCA has also taken an initiative to, to institute a CERCA chair for a period of 3 years starting January 2020. The CERCA chair recognizes faculty members from IIT Delhi for their outstanding achievements and for making a significant contribution in the field of air quality improvement. Currently, Professor Shri Harsha Kota, who is also a panelist today in session 1, is the current CERCA chair professor. CERCA also had the honor of organizing an exhibition on clean air technologies at IIT Delhi in the month of February 2020, which was inaugurated by the Union Minister of State for HRD, Shri Sanjay Dhotre. IIT Bombay, IIT Ropar, ISM Dhanbad participated in this exhibition along with various startups from IIT Delhi who had showcased the technologies developed by them. We also had the honor of hosting Professor Alan Hedge, who's the professor in the Department of Design and Environmental Analysis, Cornell University, and currently an emeritus professor, to discuss potential areas of future collaboration between CERCA and Cornell for the improvement of air quality in Delhi, including the need for substantial research on indoor air quality management area. Lastly, CERCA has installed a beta attenuation monitor at the IIT to provide a regulatory grade data on PM2.5 on a regular basis, and also to provide calibration services for low-cost air quality sensors. The last slide is exploring opportunities for collaboration. CERCA has been proactive in approaching different organizations for forging partnerships in different areas. The notable companies that CERCA approached for partnerships were DLF Foundation to explore joint projects on clean air for Delhi and NCR, such as developing a clean air plan for Gurgaon, communication outreach for school children, then documentary films, short-term workshops on clean construction management, indoor air quality improvement in malls, office buildings, and starting a clean air forum with participation from leading companies. Make my trip. The possible areas of collaboration that we explored, including long-term goals and a concrete policy for the government of Haryana for pushing air quality issues. Then highlighting important air quality concerns to EPCA, mass awareness programs, and establishing an air quality management model for Haryana and Delhi and NCR. McKinsey to develop a roadmap for the Ministry of Environmental, Forests and Climate Change to tackle the issue of stubble burning. India Paryavaran Sahayak Foundation. This is an NGO working on stubble burning issues in Punjab and Haryana. So we had collaboration meetings with the IPS for linking their ground-based experience with the satellite data analysis on stubble burning at district level, then airflow monitoring, addressing and prioritizing topmost districts, quantification of the effect of stubble burning, channelization, and appropriate targeting of funds, and fund allocation in the highest pollution contributing villages. We also had discussions with ExxonMobil for collaborating on specific research projects related to energy and environment. CERCA has now been made part of the Audit Advisory Board of the Government of Delhi to provide inputs, suggestions, recommendations on clean air matters pertaining to Delhi. This is through our collaboration and our joint meetings with the Principal Accountant General Audit of the Government of Delhi. We also had identified a couple of clean air projects with the CII of mutual interest, especially in the area of stubble burning and crop diversification in Punjab and Haryana. Niti Aayog has requested CERCA to undertake a project on carbon footprints for IIT Delhi in collaboration with Niti Aayog, which could then be replicated for other cities in India. CERCA had the honor of being invited by the Jammu Kashmir State Pollution Control Board and Srinagar to discuss areas of mutual collaboration, especially in the area of capacity building, training, awareness for the improvement of air quality in Jammu and Kashmir. We also have tied up with the Air Pollution Action Group, another organization which is active in the area of air pollution management, to develop a sensitization project on air quality awareness for the MCD staff of Delhi administration, which would be executed in 2021. And the work is already in progress. The International Center for Integrated Mountain Development of Nepal visited CERCA to discuss joint projects in the area of clean air, including exhibitions in clean air technologies developed by India. So these are, in brief, some of the important initiatives that we undertook during the year 2019, and we are moving forward with ever more positive energy, and we have chalked out an action plan for the next year also, for which Professor Sagnik will be giving another presentation. So thank you, ladies and gentlemen, for your time. And please visit CERCA at http://cerca.iitd.ac.in for more details. Thank you for your time.
Thank you, sir, for the value addition. I would like to invite Professor Sagnik Dey, Faculty Coordinator, CERCA, IIT Delhi, to kindly deliver the way forward.
Yeah, thank you, Loveleen. Is my screen visible?
Yes, sir.
Yeah. So it's a privilege to talk about the CERCA activities for restoring blue sky. CERCA is involved in alternate monitoring of air pollution and complement the existing ground-based monitoring in India. Just to give you some examples, we have generated a PM 2.5 database at 1 kilometer resolution for the entire country. And using such data, now we can actually analyze how the air pollution has changed in the last 2 decades. So for example, in this plot, you can see what is the annual climatology average over the 20-year period, 2000 to 2019. However, very interestingly, if you look into the trend, what we found is that, and in accordance with some of the recent published literature, that the air pollution is increasing at much faster rate in the eastern and peninsular India than actually in the Gangetic Plain. Also, having such data helps in understanding the recent trends in air pollution. And it's very heartening to see that recently there is a decrease in PM 2.5. So if you focus in this top panel, it shows basically what is the annual concentration of PM 2.5 in the year 2016 with respect to the previous year, that is 2015. And basically, if you now move from 2016, 17, 18, and towards 19, what we notice is that in 2019, almost everywhere in India, there is 5 to 10, 15% reduction in PM 2.5. Now, whether or how much of this improvement is due to the efforts of NCAP and how much is, probably attributed to the meteorological factors and various other important factors need to be examined. But it's really heartening to see that there is a recent improvement in the air quality. And when you zoom into 2019, what you found is that this large reduction is mainly happening because pollution actually reduced from December to September. Only in October and November, mostly in the central and eastern part of the Gangetic Plain, there is an increase in PM 2.5. CERCA is also involved, as mentioned by Mr. Hemant, that we involved in mobile monitoring to provide further information about high resolution exposure measurement. And also CERCA is involved in setting up a low-cost sensor network in collaboration with CEW, NASA, RTI, and UC Berkeley College. And we are calling this network as SAMOSA, which is basically the acronym for Surface-Based Air Pollution Monitoring Observatory in South Asia. Our idea is to provide networks all across the Gangetic Plain, and then eventually integrate all these different data sets into a hybrid monitoring system. CERCA is also working and plan to work on translating science to policy. Few examples, like we are working to develop a satellite-based tracking system for power plant emissions. For example, here what you can see that with the help of the recent satellite data of NO2 emissions over major power plants in the North India, we have developed a methodology by which we can actually calculate the NO2 emission from the power plants, and our preliminary assessment shows a very encouraging result when you compare this top-down approach with the traditional bottom-up approach. CERCA is already committed to work on several aspects of electric vehicles, which is already covered by Hemantji. So I will just mention that we are looking into the feasibility of these e-vehicles, and also CERCA is engaged in not just outdoor air but also indoor air regulations. We just finished the baseline survey for indoor air in Delhi in partnership with Society of Indoor Environment, and in future also we were working on various indoor air pollution abatement issues. CERCA also is planning, and in fact we have already started capacity building at the state level. We have recognized that the dialogue has to be moved out of Delhi, and we need to really partner with the state pollution control boards and enhance their capacity. So we have already signed MOU with West Bengal and Bihar Pollution Control Board to help them tracking urban and rural air quality, identifying open fires at the block level, then tracking water bodies and various other issues of air pollution in these 2 particular states. Then CERCA is going to lead this effort of air quality management tool for Indo-Gangetic Plain, where we are setting up a centralized unit who will overlook that overall modeling aspects of it, with technical partner NIRI and technical support from EASA, with the financial support from the World Bank. And this entire effort is in collaboration with all the state boards and the knowledge network partners of NCAP, which is listed here from Punjab to West Bengal. And this entire exercise will be overseen by a strategic advisory board where NCAP coordinator like Professor Tripathi, representatives from Niti Aayog ministries, various ministries will be part, who will time to time give advice and oversee the entire work. And the whole and the overall objective of this entire exercise is to prioritize mitigation measures based on the ease of implementation and the cost effectiveness. And also we will be developing policy scenarios for the future, mainly targeting the Indo-Gangetic. CERCA is also leading this initiative on Delhi Cluster Research Implementation and Innovation, which is a brainchild of the Principal Scientific Advisor to Prime Minister. And this is mainly to solve city-specific problem. And for Delhi, 6 themes are identified: solid waste management, water security, air pollution, machine learning in healthcare, sustainable mobility, and effective education. And CERCA, in collaboration with multiple institutes, many of them are representing here in this webinar, will address the air pollution aspect of it, where the key objective is to drive the implementation plan of NCAP, and specifically looking into hotspot management, feasibility of various intervention studies, health benefit from such studies, awareness and massive capacity building programs, addressing the legal impediments to compliance with Clean Air Action Plan, and developing sort of an open data platform for decision making at the state level, and obviously the linkages with other themes. And last, I want to highlight that CERCA is instituting an award for clean cities called CERCA Clean Air City Ranking Award under this Swachh Vayu Sarvekshan program, where we have identified a select jury, representatives from CERCA, other external eminent experts. And then the whole idea here is actually to encourage the cities to take actions and achieve success in addressing the air pollution problem. And this whole exercise will basically reward a city based on their efforts in mitigating air pollution and prompt other cities to make positive efforts in such direction. So I'm very happy today that all of you have joined for this webinar, and we look forward to the panelists. Thank you very much.
Thank you, sir, for your value addition. Now let us begin with our first session, that is Science of Air Pollution. And the moderator for this session is Mr. Hemant Kaushal. Sir, Hemant sir, you're on mute.
Thank you, Loveleen, once again. I welcome the panelists of session 1. And the theme for the session is the science of air pollution. The impact of global air pollution on climate and the environment is a new focus in the atmospheric sciences. Then the science of air pollution requires identifying different pollutants, the percentage contribution of various pollutants in different areas, identify likely areas of high pollution concentration, estimate population exposure to contaminants, predict the likely effect of various airshed management options, and intercontinental transport and hemispheric air pollution, including measuring the effect of aerosols, which are spread globally but have a strong regional imbalance and affect the global climate through their direct and indirect effect, just to name a few. Air pollution is a complex issue that is difficult to communicate to most people. And it is a hard task to explain the nuance of the science while making it engaging and interesting. The biggest challenge we face is communicating air pollution science to the general public. Though communicating this effectively can be challenging, but sometimes it is only a matter of directing people to the right information. And in some cases, some thinking may be required. So I don't want to spend more time here explaining the science of air pollution, but would prefer to move straight to the scientists who are the best experts in this field. So I have the honor of inviting our first speaker of the session, Professor Sachidanand Tripathi. Though he doesn't need any introduction, but for the sake of our wider audience who are connected with us through YouTube channel and other social media platforms, Professor Tripathi is currently a professor at the Department of Civil Engineering at IIT Kanpur where he joined in 2003. He is also an honorary faculty at the Center of Excellence for Research on Clean Air at IIT Delhi. His research focus is on air quality, climate change, human health, and nuclear reactor safety. He has to his credit many national awards, including the prestigious Shanti Swaroop Bhatnagar Prize. He is a member of various high-level committees of the Government of India and is also associated with the Center for Environmental Science and Engineering. Professor Tripathi would speak on real-time PM speciation and gas measurements. Professor Tripathi, I'll give you a wrap-up reminder 2 minutes before the end of the allocated time. Professor Tripathi.
Good morning. I hope I'm audible and my screen is visible, Mr. Kaushal.
Yeah, absolutely.
Thank you, Mr. Kaushal, and thank you, CERCA IIT Delhi, for organizing this meeting and inviting me for my talk. So I'm going to talk about some of the different kind of measurements we are doing in Delhi and other part of the country, which we call as mainly complete online speciation of PM 2.5 and some associated measurements of gases, gas pollutants. And I will discuss that how we can use them to get near real-time information about sources, and that which can be used for air quality management. And because this data is rapid, quick, and on the time scale on which some of the very complex atmospheric chemical reactions take place. So some of the insight into complex atmospheric chemistry we can also gain from these kind of measurements. So I'll just try to touch upon basically two of these broader themes. So this work has been generously supported by a couple of government agencies, Central Pollution Control Board as the chief regulator of India, and India-US Science and Technology Foundation. We had many collaborators from India, abroad, and many students and postdocs of my group and other groups have contributed to this work. So I'll start with some very simple idea that experiment we conducted over Delhi, as you see on the right top corner, that at 3 places we deployed a complete set of instruments that can give you total PM 2.5 speciations. And the details are mentioned here. And we also developed a source finder solution, which was tailored to get environmentally feasible source apportionment, if you may like to call it, and which is also mathematically sound and stable. And that is what are the 2 key important points behind these type of experiments and the inferences drawn from that. It's just to give you a primer that from one site, which is Rajendra Nagar in Delhi, we made some measurements from ACSM, and that gives you, there are 3 panels here, and which are giving you, the top one is giving you non-refractory PM 2.5 concentration, which is comprised of, as you know, organic, chloride, nitrate, sulfate, ammonium. And then you also have in the bottom is given what is the black carbon concentration. And what you see is that a very high time frequency information you can get. You see on the very left, you have very high concentration during winter time in 2018. And then as summer approaches, the number starts to go down. And what you could do from this data, you can get very interesting and unique information about sources of organic aerosols. And if you combine this mass spectra of organic and inorganic together, then you can get a very robust information about sources of complete non-refractory, that is organic and inorganic particles. This plot just shows that how you can extend similar approach to the measurements of volatile organic compounds. You know that volatile organic compounds are not only carcinogens, but they are also precursors to organic aerosols. So any mitigation strategy, any effective mitigation strategy must understand the co-emitted species, that is particulate organics as well as gaseous organics. And what we have shown here, as you see, there are 4 subplots, and they show some prominent volatile organic compounds on the very left, and next to that shows how you can source apportion them. And this is done over 2 sites in Delhi, one right in the midst of Delhi, that is IIT, another downwind of Delhi, which is Faridabad. And what you could see that this technique, because of the kind of data and the mass spectra you get, it can distinguish between type of traffic sources, which you could not do with a routine measurements which are generally conducted. Because you can get unique information about prominent volatile organic compounds. You can distinguish them between, for example, traffic 2 here is a heavy duty traffic. And if you notice over IIT Delhi, it peaks during late night to early morning hours, when during winter time, the Delhi government allows plying of these heavy duty traffic. And likewise, you can differentiate between some very, very subtle sources. This is another type of, again, very high frequency measurement, which we call a real-time metal monitor. The beauty of this instrument is that, or measurement, is that it can give you seamless information about 30 plus metals every minute. And if you combine them, you have so much of data that literally every week you can get information about sources. So the strength of the method here is that you can get weekly or bi-weekly source apportionment information, contrary to the previous method where you need to wait for a complete season in order to have sufficient data to invert that using these nonlinear regression model or positive matrix factorization kind of approaches. So what we have done here, if you see that using this 30 odd kind of metal information, and remember that each metal brings a very unique signature of a source. And if you combine several metals together, you can literally pin down a particular source. So for example, just to give an example, I'm not showing a mass spectra or source profile here. For example, if you find sulfur, lead, selenium together, it definitely is coming from power plant, because power plant has been profiled that way. But if there is a slight difference, one metal is dropped and something else is added, it still would indicate a sulfur dominated source, but not power plant, maybe roadside coal burning. So that kind of granular information you can get if you're running this rather simple instrument online all the time. And what you see here, using this kind of a data, we could classify all sources and then into 3 different kind of clusters, which you see on the very right corner. So you see one cluster shows one kind of sources are coming from northwest. Another in the very bottom brownish cluster shows that the actually tongue is going even little beyond the northwest. And then there is another source which is sitting on the southeast and northwest of Uttar Pradesh. And that's where you can get some very unique information. For example, we could
Professor Tripathi, 2 minutes left.
That you can get information about electronic waste burning. Likewise, if you club this with some kind of a bioassay approaches, you can get that how damaging these particulate matters are for health. So we could also measure oxidative potential from these measurements, which are also online, and we could get information that comparative to other places in the world, how damaging our particulate matter is in Delhi. And that is another very nice work we just got published in a top journal. Just continuing with this metal measurements, this is another point I want to make here, that what you see, there are 3 sets of measurements from 3 very distinct cities, from Delhi, Beijing, and Karakow. And if you plot on the x-axis PM 2.5 to PM 10, that gives you relative abundance of fine particle. And on y-axis, if you plot their enrichment factor, that is how relatively abundant a particular element is in the airborne particulate matter compared to its crustal abundance. You see, you can really nicely group them into 5 major sources. And this is a very kind of a unique information. This is currently under consideration for publication of atmospheric chemistry and physics. And likewise, you can get a lot of diurnal information, and you see the differences between Delhi and other places here. Finally, I would just quickly tell you that these kind of measurements can give you the information that you can give to regulator. For example, during lockdown, Central Pollution Control Board can obtain this data from us to understand how sources change during lockdown, and a traditional method cannot provide you that information in a robust fashion and in a very quick way. And finally, I will just show you that I talked about that we are not only looking from air quality management point of view, we are also looking for some understanding and deciphering some very complex chemistry which is going on in Delhi's atmosphere. And this is just to show you one plot that you see the dotted line is the data from SIMS. This is another kind of very unique mass spectrometer, first time deployed in the country. And the solid line is calculated. And what we see that unique measurement of this nitrogen pentoxide, which we found in Delhi.
Mr. Tripathi, your time is up.
The modeling or using a box model. And we are still trying to understand what's the reason behind it and what implication it would have on new particle formation. So I'll stop it here and thank you. I'll be happy to take any questions. Thank you.
Thank you, Professor Tripathi, for an excellent presentation on complete online speciation of PM2.5 and associated speciation of gases, and how can they be measured on real-time basis in Delhi's atmosphere. We also heard about the source finder tool that you have developed for source contribution, for identifying source contribution of total PM2.5 during lockdown and how it can be used effectively in Delhi. Thank you very much, sir. Our next speaker is Dr. Sumit Sharma, who is the Director, Earth Science and Climate Change at TERI. And in the last 14 years, he has worked on more than 20 projects related to air quality management, involving air quality monitoring, emission inventorization, air quality modeling, and drafting of air quality management plans. He has also worked on pollution source apportionment studies carried out for different cities in India, in which he was actively involved in preparing the emission inventory and carrying out air quality simulations. Dr. Sumit is a pass out from the Delhi College of Engineering and Indian Institute of Technology, New Delhi. Now I invite him to give a talk on source contribution to PM2.5 pollution and solutions. Dr. Sumit.
Thank you, Hemanji. Can you hear me?
Yes,
clearly?
Can hear you.
And can you see my screen?
Yes.
Okay, thank you. Okay, so I'm here to talk about our work related to the chemical transport model which we use in dairy to estimate contribution of different sources towards prevailing PM2.5 levels, not just in Delhi, but across India. And based on that, we have some recommendations. I'll start with this basic modeling results, which basically shows us the seasonal variation across the whole Indian domain. And we can see that while we all know winters are very heavily polluted, even summers, the levels at least in the Indo-Gangetic plains are quite high, and does not mean that in the rest of the country it is low. It is still much above the ambient air quality standards. Now, based on the chemical transport model, we also could find the contribution of different sources at the India average level. Now, what you can see here is this, sorry, I need to shift it. Yeah. You can see these blue bars, which are basically representing domestic contribution. And then you have industrial contribution, which is quite significant. And this is for India, sorry. You can see that the residential contribution, which is the blue stack at the bottom, is in the range of about 15 to 25% at an India average level. Industrial contributions are also in the similar range of 20 to 25%. The transport contribution at small, it is between 5 to 10%. But the moment we shift our focus from India to a city like Delhi, the contribution of transport suddenly becomes very immense. And you can see that what we found is in the range of 20 to 25% is the contribution coming from transport sector. And certainly the contribution of biomass burning in rural kitchens goes down to about 10%. Delhi does not have many industries. I mean, there are some, but most of them have been converted to gas now. Despite that, we are still getting about 25% contributions from industries, indicating towards the long-range transport and contributions from outside of city of Delhi from the industrial sector. We also did this analysis of lockdowns using the models, and what we found is that we compared 2019 and 2020, and you can see that there is hardly a difference in the concentrations in the month of January. The February month is also quite similar, but the moment you get into lockdowns from March, you can see that the air quality certainly starts to improve, courtesy to the sectors which have been restricted to operate: industries, transport, construction, and all these things. April was even cleaner. You can see the drastic difference in air quality levels in 2019 and 2020. May also was relatively cleaner than the 2019 year. Now, what we did was we estimated the India average reductions which we got during the lockdowns, and we could estimate it to be in the range of 30% at the India average level. We also did how the source contributions changed, and you can see that because industries and transport were shrunk down in 2020 due to lockdown, were widened, and the share went up from almost 18 to 26%. We also did this source apportionment analysis for Delhi during the lockdowns, and you can see the results of simulated and observed values. The model was able to capture the concentrations quite well, even during the lockdown periods. And again, the source contributions in Delhi in January and February, they look very, very similar during 2019 and 2020. But the moment you get into March and May, you can see quite a difference in the values, as you can observe that the industrial sector and the transport sector were shrunk down, while other sectors had wider shares in the overall concentrations. We also were using some low-cost models for further PM2.5 assessment. This is using the artificial neural network technique for PM2.5 forecasting with 2 days in advance, and this is quite nice reproduction of the PM2.5 concentrations was observed using the model, and this is working quite fine. Another thing which we use is a spatial mapping tool, which is actually dependent on the air quality monitoring data sets produced by 40 odd monitors in the city of Delhi. And using those monitors and land use regression technique, you can actually spatially plot the concentrations over the whole city, and you can find the hotspots here and there, and you can take care of those. Now, using the spatial model also, you can actually see the effect of lockdowns, and you can see the concentrations were much higher in January, and then slowly they start to improve. When you came to April and May, they actually went down close to 50 micrograms per meter cube of PM2.5 levels. So this was the science part of it. Now just coming to some of the issues related to air quality management in India. There are some aspects on which we have made some progress. A lot of source apportionment studies have started. People have now started realizing the importance of regional. There's a lot of stuff which comes from outside of the city, and that also needs to be controlled. AQMPs are being finalized based on scientific information. Up till now, a lot of cities were moving ahead with a wish list of things to be done, but more scientific information is being taken into account while making the AQMPs. The monitoring network has enhanced. There are a number of strategies like Euro 6 implementation, the LPG penetration, which has gone further ahead in the last few years. And resultantly, we can see some slight improvement in the air quality levels of some cities. Does not mean that we have won the battle. It's just a directional change we see in some cities. And there is a lot to be done because the levels are humongously high than the standards. There are a number of lagging issues. The processing of the budgets allocated is a big issue. On what basis it is to be done, when it is to be done, and how we can maintain the flow of budgets in this area is a question. The enforcement, agricultural residue burning. Well, we are in September. We are now waiting for October. Let's see what happens this time. But we are still not very hopeful that this will be a bright, clear, sky in the month of October and November, and we expect the residues being burnt, unless there is dramatic control or enforcement in this time. Older vehicles is a major concern as we move to Euro 6 standards. Unless we modernize our fleet, unless we improve our inspection maintenance system, the older vehicles will continue to pollute, and that needs to be strengthened. Electric vehicles is making their ways, but I think the pace is slow, and further movement is required in this to make this happen much faster. LPG is something which is reaching to the masses,
Dr. Sumit,
but still underprivileged are much okay. They are much away from this, and that the penetration needs to improve considerably. And the capacities to enforce, what we feel is that the manual way of enforcement is not going to work across the whole country. We need to make use of technology to make our enforcement program much more stronger. As I think someone mentioned, the integration of satellite low-cost monitors can work wonders in this country, and we need to work in this direction. And of course, forecasting system is something there. Now, my last slide is on strengthening the overall national clean air program. We heavily recommend carrying out regional scale assessments, not just regions around the city, but for the whole states, so that you look at things in one go. Assessment and control of secondary pollutants. Professor Tripathi spoke about these things. These are very important. A very significant part of PM 2.5 is actually organic secondary pollutant and inorganic secondary pollutant that needs to be tracked and controlled. And for that, we need speciation networks. Unless we track the species of PM 2.5, we will never be able to make progress. Professor Tripathi's group has done a number of studies in this direction. And of course, there is a need to integrate policies in the air quality and climate space. There are a lot of synergies where what we estimated that in India, you can automatically reduce PM 2.5 levels by almost 13% in next 15-20 years. Then, of course, the use of low-cost models is something which we are advocating. Forecasting is a requirement in a scenario where pollution levels are so high, and low-cost forecasting techniques can be employed for advising people in advance. Of course, strengthening enforcement is something which is required, at least in the industrial sector, which in my opinion is a left out sector. We are working on residential, we are working on transport. Industry is something which is left out. The norms are to be made. Okay, the norms are made to be more stricter, and of course they need to be enforced with more energy for further control. Thank you, Emanji. I just close my presentation.
Okay. Thank you, Dr. Sumit, for your presentation on source contribution to PM 2.5 pollution and the solutions. We heard about your work on the average relative source contribution to PM 2.5 for India and Delhi, in which industry and transport are the biggest sources. We also heard about modeling analysis used during lockdown, changing source contribution in India and Delhi during the lockdown period, and the use of forecasting tools for PM 2.5. Also heard about the spatial mapping using monitoring station data sets in Delhi in 2020 and your plan to strengthen the National Clean Air Plan. Thank you very much. Now I invite our third speaker on the panel, Dr. Sarath Guttikunda, who is the founder director of Urban Emissions India, an independent research group on air pollution founded in 2007 that disseminates air quality forecasts for 640 districts in India. Dr. Sarath is a TED fellow and a trained chemical engineer with the research interests that follow from his thesis work on the impact of Asian megacity emissions at a local, regional, and global level from the Center for Global and Regional Environmental Research at the University of Iowa. He is also a developer of the SimAir, which is called Simple Interactive Models for Better Air Quality family of tools, dedicated for sharing information on air pollution and climate change among the developing country cities with applications in Delhi, Pune, Chennai, Dhaka, Manila, Hanoi, Shanghai, Lagos, and Tanna. Dr. Sarath would be speaking on open data resources for energy, emissions, and air pollution analysis in India. Dr. Sarath.
Hi, thank you. You can see my screen and listen and hear me.
Yeah, we can see that.
Okay, hey, thank you.
A little louder, Dr. Sarath, a little louder.
Okay. In the last two presentations, we saw a lot of information on modeling and monitoring. And one question that comes up a lot is where is the data? And to not only to model, but also if some monitoring work is happening, where is the data that can be used? So I'll quickly go over what kind of resources that are available for us in India to do some of this analysis. One important point is, even though we talk about open data, it doesn't mean that it comes without any effort. I mean, you really have to work on that data to make some stories around it. A good place to start is actually all the official portals. And this is something that we really neglect on looking at. A lot of these, for example, NGT and EPCA, there are a lot of documents that are filed by different agencies, not only NGOs and official groups, but also different industries. And there's a lot of information that can be gathered from these documents that can be used for modeling exercises. And not many groups actually go there and look for this information. It's really important that we start looking at the base of the problem to understand what is being used for, whether it's policy discussions or also trying to understand what's the depth of the problem is. And we also have a lot of environmental standards, and all these documents are available online, and we should start exploring more of these to understand what is happening in these industries. Okay. And the two sides of the air quality data that we've seen in the last presentations, one is the monitoring side, and then other thing is the modeling side. And both the efforts take a lot of information to come up with a very clean slide and a clean pie chart that we saw in those graphs. And let's start with some of the monitoring work. This was stressed in the previous slides as well. We don't do enough monitoring. This is something that really needs to step on and do more. So we have about 232 continuous monitoring stations operational now, and there are some manual stations that are operational, about 750 manual stations. But we really need to increase this. Compared to China, when they are operating 1,500 stations, and all that information is available and freely accessible. And technically speaking, we really need 4,000 continuous air quality monitoring stations. When they don't have to be all reference grade systems, but even non-reference grade systems, low-cost sensors, it will really help us increase this, increase our understanding of what is happening on the ground. And you can access all this information directly from the CPCB's website, but also from another portal, openaq.org, where you can easily get a CSV files and start using it. So there are a lot of other portals where you can access this monitoring data. So you have the NAMP network, the manual stations network. You can have a series of information on the trends over year by year. And then you can also get monthly air quality index bulletins. We don't really look at it, but there's a lot of information in these bulletins that are issued every day. We should start exploring that. When we have compiled some of this information and put them on our website, you can access that directly. Another network parallel to CPCBs is SUFFER. You should go check it out. I mean, they operate a network in 4 cities, Mumbai, Pune, Delhi, and Ahmedabad. And you have these low-cost sensor networks. All of them have their own websites. It may take some work to do some back-end data extraction from these sites, but there's a lot of information there that should be used. There's a lot of emphasis on satellite data, and this is something that, again, people ask for it, but they don't know where to access this information. IMD, the Indian Meteorological Department has a lot of these data feeds available on various portals. One is a rapid portal where you can actually see within a couple of hours INSAT products on AOD, lightning, dust storms, and a few other things. So you can easily go and look at that. And ISRO Dehradun hosts another portal where you can go and visualize some of these products, and they have translated information from the INSAT feeds, and they have a modeled PM 2.5 maps that are available. Mind that all the information that you have on these portals are images only, but if you need the data itself, you have to write to them and sign some NDAs and get that information and start using it. Of course, there's a new feed similar to Tropomi over the Sentinel feeds, which are geostationary over US, over EU. So there's a new satellite which was launched last year called GEMS. So this is geostationary over Asia. So once it's operational, we'll have a lot more feeds that are coming in that will be integrated into these portals. There are, similar to what we see from INSAT, there are a lot of other satellites that are available across the globe. They will give you snapshots for different products, not only for pollution, but also for meteorological feeds, fires. The animation that you see here is fires every day, and dust storms, lightnings, and things like that. So it's really important that you start exploring these data feeds to understand on a larger scale what the problem is. Again, it takes a lot of work. It takes a lot of computational power and storage to access these things, but it's definitely possible to look at a lot of this information and use in a good way. A lot of GIS and information is required for mapping, and this is something that we really need to start focusing on. One is the satellite feeds, but also a lot of process information that's now available that can be used. As simple as population data. You get the population data now at 30-second resolution. For multiple years, you can also access that at various spatial resolutions that can be used for some of the backend modeling and also for spatial analysis. Road network, it's really a critical one in understanding where is the road, how big is the road density, can be used for spatially allocating emissions from transport sector, trying to understand where are the urban hubs. So a lot of information is available from the OpenStreetMaps. They have very neat scrapers that can be used for extracting this information. The new feed that's available now is Global Human Settlements. This is basically a feed for understanding the urban built up. They go back to 1975. So if you want to understand how the built up has changed between 1975 and 2015, they have all this data available, and this is open and easy to access. Easy is very relative, but you really need to work on that. Compiled emission basis. I mean, you saw in Sumit's presentation how emissions inventories can be used for modeling exercises and trying to understand both spatial and temporal allocations. So that takes a lot of information on the emissions. There are some regional and global emission inventories available for use, and we compiled some of those. Most important one is the Smog India. This is from the Indian Institute of Technology, Bombay, Dr. Chandra Venkatraman's group. This has been extensively used in the global burden of disease estimates and continue to be used in the new developments that are coming up, new reports that are coming up published by Public Health Foundation and ICMR in understanding the loads of the contributions of different sources at the state level. So you should definitely look out for some of these. And one sector which has extensive reports online is, of course, the forest fires and agricultural fires. Different groups post this information both as raw satellite feeds and also as processed feeds. There is also reanalysis data. If you don't have the capacity to do your own emissions modeling and your own chemical transport modeling to understand the spatial and temporal trends in pollution, so you can start accessing these reanalysis feeds. So there are groups who combine meteorology, emissions, and the chemical transport models and satellite feeds, and they produce these very nice estimates at different time scales. And we can use this to to build stories on this. It's a very important one. A shout out to Sagnik Day's group, SARS program. This is, I think he showed it in one of his first slides. So it has a reanalysis model for last 20 years. Should definitely go in and look at it. It's a very high resolution, 1 kilometer data, and can be used for building these stories. So some of these data feeds we have extracted and we build stories and we post them online. So you should definitely go and take a look. So like this, every sector has their own portals. It's definitely, it needs some work, but should go and explore that. For fires, dust storms, lightning, maybe I showed you some of the examples. For transport sector, for aviation, AirSeva is an excellent place to go and collect this information.
Your time is up.
Yeah, last slide. And like this, every sector has a lot of databases that are open. It just needs a little bit of massaging, and you can start exploring some of these. Health impacts, there's a lot of data that's available there. Please go and explore that. Again, Sagnik Day's group has done a lot of work. We put some links here. And most importantly, don't wait for the perfect database. It will not magically appear. A lot of data is open, available. You just need to start training yourself and trying to find the best available information that can be used for some of the modeling activities. Thank you.
Thank you, Dr. Saab, for a very informative session on open data resources for energy emissions and air pollution analysis in India. We got a lot of information, about various data sources for monitoring air pollution, like satellite feeds, various online portals, blogs, organizations, GIS and map data sources, compiled emission data sources, reanalysis data sources, and sources on the health impacts of air pollution. Thank you very much. Now I invite our fourth speaker, Dr. Shri Harsha Kota, who is currently an assistant professor of civil engineering at the IIT Delhi. He received his master's and PhD degrees in civil engineering from Texas, College Station, US, and his research is focused on developing emission inventories from mobile sources and landfills, urban air quality monitoring and modeling, noise pollution, developing indoor air purification systems, regional air quality modeling, and climate change. Professor Harsha.
Thank you, Hemant. Hopefully I'm clear and my slides are visible as well.
Yes.
Yes. Good morning, everyone. Thanks for the organizer, Dugalji, Hemant and his team, Professor Day, everyone, and the eminent panelists on this most important day on air pollution in the year. So my topic is looking beyond particulate matter in India. So as Hemant has introduced me, I'm an assistant professor in Department of Civil Engineering. Recently from January of this year, I'm also a chair professor in CERCA in IIT Delhi. So brief introduction, status of air quality and the learning from lockdown, based on which my topic of today will be discussed. So most of the work is from my group, which is Urban and Regional Air Quality Management Group of IIT Delhi. So we know that particulate matter is one of the most dangerous pollutants in the world and also in India. This is pretty evident from the WHO reports which come up, and invariably most of the, for example, this is the report which we are seeing is 2019's cities, polluted cities. We see most of the cities are actually clustered in India. This itself shows how bad or how severe is PM pollution in the country. So we know particulate matter has different health effects. I'm not going to go through the details, but in general, you have lung cancer, stroke, IHD, COPD, many health issues. So it has significant coverage in the media, both in India and abroad. Even abroad, they coming winter and post monsoon, our air quality in India will be discussed in many media channels abroad as well. So that shows how significant is air pollution in the country. So status of PM related air pollution in the country. So this plot shows clearly that at least in the cities in northern and eastern India are more polluted than the southern part of the country and western part of the country. So based on the chemical transport modeling, which is what Dr. Sumit Sharma was discussing, we see there's high pollution in winter and post-monsoon compared to pre-monsoon and monsoon. And when we talk about the composition, these are the following conclusions we can come up with. Southern cities are relatively cleaner in terms of PM 2.5. Primary organic aerosol, then sulfate are the dominant pollutants. Fractions of PM 2.5 in north and eastern India. Nitrate is more in winter. Sulfate in southern India is more. Fraction of sulfate in southern India is actually more compared to other parts, other cities in the country. So naturally, this gets related to the premature mortality, and we see that significant mortality is associated with PM 2.5 alone, and also to the years of life lost. And we always find out that in northern Indian cities like Delhi, PM 2.5 itself is responsible to around 2 years of life loss, which is a significant number. So the mortality for different states and for India together, it is around 1 million deaths per year, which is what with other reports also come up with, close to 1 million deaths per year, which due to PM 2.5 alone, which is a significant number. And when we do the source contribution, we see residential is the main source for this mortality in the country. So now, knowing that once we know PM 2.5 is dangerous, the next task would be gradually to understand the source composition and then try to regulate the dominant sources so that the overall concentrations of PM 2.5 will be meeting the standards. So, and this is the basis for many clean air plants in the country, NCAP, which significantly, which I would say is a milestone in India in terms of air pollution, where different sources and with specific targets have been identified by the government of India, and many non-attainment cities were identified, and most of the cities are coming up with the clean air plans, which includes source apportionment, of course. And the different techniques to do, one could be using a filter-based modeling, or it could be a real-time monitoring, as what Professor Tripathi was discussing, and could be simple low-cost air quality modeling, or it could be fancy models like any chemical transport models like what Dr. Sarath Kutikunda and Dr. Sumit Sharma were mentioning. So the understanding is clear from all these slides that PM 2.5 is the dominant pollutant and we need to act more on it. So most of the air quality action plans in the country are revolving around PM 2.5. So now lockdown has actually shown us, given us a peek into what would happen to our country if we are very successful in regulating sources of PM 2.5 in general. So we all know about status of COVID in India. The graph is still going up. Hopefully it will come down, and the related events. So generally from most of the results we see that PM 2.5 concentrations have been coming down in most of the cities during lockdown. Especially concentrations have come down significantly, except some events when there were dust storms and all. However, to understand it better, this study, I'm quickly going to show the concentrations in for 4 different years from March 16 to April 14, the first lockdown, so that we know how significant was restricted emissions on air quality in those cities. So this is for PM 2.5 and PM 10 in different cities in central, eastern, northern, southern and western India. It is pretty clear that in most of the regions, PM 2.5 and PM 10 concentrations have actually decreased in the lockdown period in 2020 compared to the same period in 2017, 18 and 19. Right? So this itself shows lockdown this gives significant hope to the regulators and also the public of India that a better action plan which is properly implemented can help us get away with the dangers associated with PM 2.5 and PM 10. But when we look at other pollutants, the picture is not very similar to what we have for PM 2.5 and PM 10. In fact, some pollutants concentrations are actually increased. For example, ozone increased in some regions. So this is also reflected in the excessive risk, where we see that in lockdown time, the risk, if the lockdown concentrations exist throughout the year, then the risk would be slightly more compared to what happened in the previous years. Now, this graphic will show what is happening to the dominant pollutants of AQI. So different symbols are given in the bottom, and the color gives of the AQI gives
2 minutes left.
Yeah, severity of air pollution. And this clearly shows that compared to 2017-2020, the number of triangles and rhombus which we see are converting into circles or rectangles. This is so the last column here, which is for 2020, which is highlighted, which shows that number of cities which have now transferred to non-PM 2.5 dominant cities. When we estimate AQI, we also estimate which is a dominant pollutant. So in these cities, looks like PM 2.5 is was no longer the dominant pollutant, and other pollutants have started to take over, especially ozone. So let me conclude. So what do we understand from this? This is something which has happened very similar in China as well. Because of the clean air action plans in China, PM 2.5 concentrations have come down significantly. However, their ozone concentrations kept on building up. The same thing is currently being observed in the country. While PM concentrations are coming down in many places, ozone concentration is starting to build up. So, and now the action plans in China have been revised such that even ozone pollution can be put in check. This is the time that India as well start acting. We are doing MCAP is doing a great job that that PM 2.5 concentrations are under check. So this is time that we also invest in controlling other pollutants as well, so that we might not end up instead of having one kind of smog, we end up having a photochemical smog in Delhi in future. So this is just what I would like to conclude from this presentation, and looking forward for other presentations. Thank you. Thank you, Hemant.
Thank you, Dr. Harsha, for your excellent presentation on the need to look beyond the size of particulate matter alone and consider careful evaluation of other factors that impact human health. So there needs to be a broader consensus now between air quality, health, and urban management, and it's time that we focus on the source of pollution to figure out solutions to it. So we heard about the premature mortality and years of life lost due to PM 2.5 in India in different states. We also heard about the effects of restricted emissions during the COVID-19 on air quality in India, and the need to focus on the reduction in other pollutants, especially ozone in India, similar to China. Thank you, Dr. Harsha. Now I invite our last speaker of the session, Professor Dilip Ganguly, who is an associate professor in the Center for Atmospheric Sciences at IIT Delhi. And Dr. Ganguly's broad research interest is to investigate the role of aerosols in the climate change mechanism through their influence on the radiative transfer of the atmosphere and cloud microphysical processes. The tool that he's currently using is climate modeling, and he has expertise in modeling the production, transport, transformation, and removal of atmospheric aerosols in general circulation models like AM2, AM3, and CAM5. He also uses remote sensing data from satellites as well as in situ data. Dr. Ganguly would be delivering his talk on air pollution, climate interaction, and co-benefit opportunities. Dr. Ganguly.
Good morning, all of you. I'm unable to go back to my first slide.
You need any help, Professor Ganguly?
Yeah, can you see my screen?
Yes, we can see. Make it full screen, please. Perfect.
Okay, good morning, all of you. And first of all, let me thank Professor Sagnik Dey and Hemant Kausal for inviting me for giving a talk in this CERCA webinar on the occasion of International Day for Clean Air for Blue Skies on the topic of air pollution, climate interaction, and co-benefit opportunities. So, as all of you know, that air pollution means basically the presence of undesirable substances in the atmosphere. And we can classify these air pollutants in the atmosphere in terms of their sources of origin, like some of them are anthropogenic, some are biogenic, some are natural. We can also classify them in terms of their physical state. Some are gaseous and some are particulate matter or aerosols. We can also classify them in terms of their production mechanisms. Some of them are primary air pollutants, some are secondary air pollutants which are produced through chemical reactions that happen in the atmosphere. So it's quite complex. So now air pollution has a complex relationship with climate change. While air pollution effects on climate in a variety of ways, climate change also can provide feedback to air pollution by affecting the production and the distribution of air pollutants in the atmosphere. And depending on the physical and chemical characteristics of the air pollutants, they can either warm or cool the climate. And broadly, air pollutants, basically, they impact the climate through either through their interaction with the short wave and the long wave radiation. So both the gaseous and particulate matter interact with the radiation, and thereby they have an effect on the climate. But the aerosols have another pathway of affecting the climate, and that is through their interactions with the clouds, and then further feedback on the climate. And unlike carbon dioxide or other well-mixed greenhouse gases, most of the air pollutants have a much shorter residence time in the atmosphere, and hence sometimes they are also termed as short-lived climate pollutants. So although most air pollutants have a much shorter residence time, however, due to their indirect couplings with the other components of the Earth system, their impact on the climate can be prolonged over a long period of time beyond their own residence times. And air pollution often causes are found to have result in basically more stronger local and regional perturbations to climate, even if their effects on the global climate sometimes is found to be very small, but they have a very strong local or regional perturbations to climate. And air pollution effects on precipitation or rainfall is actually more complex, and it's not very well understood. For example, here I'm showing as an example the work done by Jivan Fan where they showed that air pollutions over China actually amplified extreme weather and floods in China. So this happened according to their research. They found that aerosols from heavy air pollutions, basically they absorb heat from the sun, they stabilize the atmosphere and suppress the local storms during the daytime. However, this allows heavy and moist and now warm air to be transported downwind to hilly regions where it is lifted and causes extreme nighttime precipitation. So this is just an example. And this is another example of basically aerosol effects on extreme weather events. So this is a work that was carried out by Chandan Sarangi, who used, at that time he was a PhD student of Professor Tripathi at IIT Kanpur, and now he is a faculty at IIT Madras. And I was also involved in this particular work. So here basically we looked at aerosol induced intensification of cooling effect of clouds during the Indian summer monsoon season. So using a variety of observational data as well as through numerical modeling, what we showed is that compared to a cleaner atmosphere, if there are in a polluted atmosphere, particularly if that polluted atmosphere contains more absorbing type of aerosols, then those absorbing aerosols can actually modify the lower tropospheric stability, and those aerosols can actually invigorate the clouds, resulting in more taller thunderstorm clouds with thicker stratiform anvil decks, which then basically reflect the short wave radiation more efficiently, resulting in a cooling effect at the surface. And we also showed in our model simulation that this because of this cloud invigoration, what happens is that instead of during the monsoon time, instead of more frequent rainfall with lesser intensity, we are likely to have, if there is more absorbing aerosols present in the atmosphere during the monsoon time, it can lead to basically long breaks in the monsoon time, but followed by very strong and heavy precipitation events. Now, climate change and air pollution are interlinked with each other, and improvements in air quality therefore also has an impact on the climate change. However, while the controls of anthropogenic emissions such as of air pollutants clearly leads to a win-win situation for both air quality and climate change, controlling the precursors of certain secondary air pollutants like ozone, which is a secondary pollutant, are not always clear. For example, if we, as an emission control policy, we decide to cut down the emissions of sulfur dioxide, so that will lead to lesser sulfate, formation of lesser sulfate aerosols in the atmosphere, and therefore it will lead to eventually a warming of the atmosphere. However, if we decide to control the emissions of, for example, NOx, which is a primary air pollutant, but it's a precursor for secondary air pollutants like tropospheric ozone, which is again a greenhouse gas. So basically, NOx emission controls are expected to have a cooling effect as they reduce the production of tropospheric ozone, but they also in turn result in the decrease in the lifetime of methane, which is also a greenhouse gas. So you are increasing, although you are decreasing the production of surface ozone, you are increasing the lifetime of methane, and also you can lead to lesser production of nitrate aerosol. So eventually you can lead to a warming. So therefore, what I mean to say is that controlling air pollution to achieve a certain climate goal can be very tricky. So it has to be, we have to do this in a very, we need to understand all the processes involved in how air pollution affects the climate. Now, as I said, air pollution impacts on the climate change itself is a very tricky business, but controlling the air pollutions to regulate air pollution itself or the air quality can itself be a tricky thing. So this I'm showing you some preliminary results which are obtained from by doing some simulations using the WRF model. So during the recent lockdown period, basically we wanted to understand the contribution of different emission sectors. So if you shut down, for example, because during the lockdown period, we actually shut down many emission sectors. So we wanted to understand if you shut down a particular emission sector, how much the level of air pollution over India will come down. So we performed basically a series of numerical experiments using the WRF model by shutting down the emissions of various short-lived climate pollutants from different sectors in a very systematic manner to understand its impact on the regional air quality and its consequences on the climate. So what we found is that, so we shut down, here I'm showing you the results where we shut down simultaneously 5 different sectors: transportation sector, energy sector, industrial sector, agricultural sector, and trash burning sector. So, and here I'm showing you the top panel shows basically the simulation of black carbon or PM 2.5 or CO or tropospheric ozone in our control simulation, and the bottom panel shows when you shut down these 5 emission sectors together, what is the change in you see for BC or PM 2.5 or CO or tropospheric ozone. So 5 different emission sectors resulted in basically drop of PM 2.5 across India in the range of 5 to 25% of their climatological values. However, the changes in the secondary air pollutants such as surface ozone by shutting down of the primary emissions from various sectors are found to be more complex and nonlinear. So when we shut down different emission sectors, so we can see that clearly BC levels have come down, PM 2.5 has come down, CO has come down, but what we found is that over northern India, the surface ozone has increased. And this has happened because you are decreasing, by shutting down the emission sectors, you are decreasing the amount of aerosols present in the atmosphere, and therefore you are actually increasing the availability of sunlight, and which is resulting in a more stronger photochemistry to happen. So there is a more increased production of surface ozone happening. So therefore, although you are able to cut down the concentration levels of primary aerosols, but the secondary aerosol levels can increase in certain cases. So air quality controls for mitigating air pollution itself is quite tricky. So therefore, air quality controls for mitigating climate change by targeting basically specific anthropogenic activity sectors such as transportation or energy or other sectors can be even more trickier business, because reductions in co-emitted species within a targeted sector could lead to complex mix of atmospheric chemistry and therefore the climate perturbation. So unlike the long-lived greenhouse gases regulations, control in air pollution levels of SLPCs can produce immediate effects on the climate. So this is an advantage, that you can see the effect on the climate rather at a faster rate compared to if you decide to bring a regulation on controlling the greenhouse gas emissions. So this is I'm showing a paper published by Schumacher et al. Along with Professor Ramanathan in 2013, where they showed that basically there is a business as usual scenario where the temperatures by the end of 21st century is likely to increase by more than 3.5 degrees Celsius. But if you bring down the emissions of CO2 alone, the temperature, you can bring down the temperature levels, global annual mean surface temperature levels significantly. But they also showed that if you mitigate the emissions of these short-lived climate pollutants like BC or CO or NOx or other air pollutants, the combined effect can give you
Professor
much
Ganguly,
better
your time
results.
is
So
up.
combined, when combined with significant measures to cut the carbon dioxide emissions, short-lived climate pollutants can play an important role in slowing the rate of global warming and achieving the 2-degree target set by the Paris Agreement. So finally, I'm coming to the summary of my talk. So air pollution has a very complex relationship with climate change, and therefore more research is required for better understanding, quantification, and modeling of various processes, including feedbacks, in order to clearly understand the overall interaction between air pollution and climate. And therefore, scientific community must work towards developing combined policies to tackle effectively tackle both climate change and air pollution problems. However, scientific community has demonstrated that in spite of several uncertainties involved in the estimation of air pollution impacts on climate change and vice versa, there are clear benefits of controlling the emissions of short-lived climate pollutants along with the greenhouse gases for mitigating climate change. Thank you.
Thank you, Dr. Ganguly, for a very informative presentation on the interactive relationship of air pollution with climate change. We heard about emission shutdown experiments using the WRF CAM model to understand the immediate impact of air quality as well as its consequences in the regional climate, and also for the need for controlling emissions of SLCPS for climate mitigation policy. Thank you, Dr. Ganguly, once again. So now we come to the question answer session of session 1. We have a couple of questions for panelists. So let me come to the first question, which is for Professor Tripathi from Professor Sagnik Day. This is Professor Tripathi. Since this type of measurements, they require skill and resource, what is the best way to develop such a network across the country? Professor Tripathi. This question is posed by Professor Sagnik to Professor Tripathi.
Thank you, Hemant. Yeah, definitely this requires resources, but as we know that air pollution, managing air pollution is a costly business because otherwise one might be paying much higher cost, as it has been shown by several people in this meeting itself, the health associated or related cost. Just to give an example that there are many research labs and academic institutions who have obtained some of these instruments, including IIT Delhi. They have started doing measurements, and for example, ISRO, Ministry of Earth Sciences, Indian Institute of Science. So measurements which started from IIT Delhi back in 2012 has now spread over the country. Now there are two ways to go in that direction. One is that the people, they come forward on their own, join hands and start doing these measurements. And the second way is that where the funding agencies support it. Now, just to give you an example that I am told, and I think is quite true, that Paris itself has 19 such sites where they are doing mass spectrometry based measurements. And China, for example, Beijing has 6 sites where they are using the complete set of instrumentation, which I discussed in my slides today, where they are using it for episodic, or critical episode related management issues. So I'm sure that we have to invest in that in order to do that, and the capacity building must go hand in hand.
Thank you, Professor Tripathi, for answering this question. Another question posed to Dr. Sumit Sharma from Sagnek is, we are not utilizing the forecasting for taking prior action. Rather, we act once the air quality plunged into severe category. What's your thought on this? Dr. Sumit.
Well, absolutely. I fully agree to Dr. Sagnik Day's comment. This is the problem that, forecasting is something which has, I would say, just started in India. In Delhi, we get forecasts from SAFAR and a few more cities, But if you generally see the tendency to manage air quality is more or less ad hoc, if I may use this word, and we are not relying so much on the forecasts which are available to us. One problem is that the forecasts are there for 2 days in advance or maximum in 3 days in advance. I'm talking about the reliable forecasts, and probably this time is not good enough to drive things in so many sectors. That's one issue which is there. But despite this, I must say that even in 2 to 3 days, a lot of mitigation action can happen on a proactive basis, and more and more familiarity with the forecast and the improvements in the forecast can build that confidence that if we take proactive actions, we can lead to a situation where the high air pollution episode is not there. Thank you.
Thank you, Dr. Sumit, for taking this question. Another question from the audience that we have is from Rijul Dimri. I think it is addressed to Professor Ganguly. Is aerosol size plays any role in summer monsoon cooling? Professor Ganguly. Professor Ganguly?
Yes, I'm listening.
Yeah.
No, what our study showed is that it is the absorbing capability of the aerosol which results in cooling effect that we observed. It leads to invigoration of the clouds, and eventually it leads to cooling. So size is not that important. We did not investigate that also. So we found the chemical composition of the aerosol, particularly its ability to absorb radiation and heat up the atmosphere, and also so thereby participate in the cloud invigoration, plays the most important role.
Thank you, Professor Ganguly. A question posed to Sarth Guttikunda. We have, by Professor Sagnik Day, we have 650 plus manual monitoring stations, but they are highly underutilized, and how to make use of them in the best possible way. Dr. Sarth.
Hi, thank you. Yes, the manual data is also very useful. I think one way of making it more widely useful is doing some chemical analysis on these filters. I think that will take some additional changes to the way samples have been collected, but I think it's definitely possible. So right now, most of these are high volume samplers, which means that the filters themselves are very heavy and heavily loaded. But this small change in the way it's filtered, we'll have a lot of information that can be gathered from chemical analysis by way of chemical analysis and can be used. I mean, right now it's only used for putting out that air quality index values and just for some PR activities. But there's a lot of potential in expanding that network.
Okay. A question which is, I think, posed to Dr. Sumit Sharma by somebody, who's not written his name, but there's some other name which doesn't look like any person's name, but anyway, how lockdown can remove pollution? Can strike in industry be a boom if lockdown is a success?
Well, we have seen a reduction in air pollutant levels during lockdowns, and that's mainly because industries were not functioning, people were not moving out. So the costs of improved air quality were immense, and this is certainly something which is not desirable, I would say. We can achieve better air quality with much lesser costs if we can put right technologies, right management measures in place. And in that case, you don't need to shut off your industry. You don't need to stop moving. But you can actually de-link your economic growth with the emission intensity, and the emission intensity can actually go down without impacting economic growth with the right technologies in place.
Okay. A question from Harshal Salve to Dr. Sumit. What is the impact of lockdown on HAP in particular?
Well, we have only assessed PM 2.5, as a total. I think by HAP he means the hazardous air pollutants, and PM 2.5. I mean, some part of it is more hazardous. There are oxidative potential studies.
Can I say
which,
HAP is household air pollution?
You're talking about household air pollution.
Yeah.
Okay.
Sorry.
Now, household air pollution is something which has not, been seen to be impacted so much during the lockdowns, and because well, industries were closed down, people were not moving. The residential sector more or less remained intact, although there was some free cylinders which were given to the underprivileged people, but the overall share of residential sector was found to increase because other contributors have gone down in their contributions.
Okay. We have a question from one Vamsi Sai Krishna Palwadi to all the panelists, especially it is addressed to Dr. Sarth Gutikunda. What is it that takes to develop a city-wise inventory across India? And what policy changes in the operation of CPCB and SPCBs in attaining this target? Working in industry, we understand the importance of inventory, which we are planning to develop in the near future. Dr. Sarth.
Hi, thank you. One, as I said in the presentation, you need a lot of data. There's a lot of data is available. So what's missing right now is a full-scale institutional support to massage that information and start using it for building inventories and conduct modeling at a very small scale, at an urban scale. A lot of different groups are working on it. So it's a work in progress. The NCAP program by CPCB and SPCBs, it's a good start. They're providing some institutional support, but what's really missing is a full-scale institutional and financial support to make it a full-blown program that can be sustained over periods. Right now, it just looks like one research project at one time, and as soon as the NCAP program finishes in 2024, we don't know what will happen. So we need a full institutional support with a long-term planning for taking it forward.
Okay. This is a question which is posed by Professor Sarganek to all the panelists. Anybody can take this question. Since multiple emission inventories are available for India, they sometimes create more confusion rather than a solution. How should we converge on a national emission inventory? Dr. Sumit or Professor Tripathi can take this.
Well, Professor Tripathi, do you want to go ahead first, sir?
Yeah, I think that's a very important issue that different labs, different agencies and people have been developing, and so that creates problem. I mean, in terms of having a seamless integration of these emission inventory in various modeling tools, what people are using. So in that direction, there is a good initiative, I would say, which is in the PPP mode is happening, where one top think tank has come forward. And I think and CPCB is important, you can say, stakeholder in that. And they are working with Knowledge Network to National Clean Air Program to develop emission inventory, what they call national emission inventory, but this will be city-wide. So for all 120 non-attainment cities, they are planning to develop this emission inventory. So probably in some way, this would address the issue what Sarganek is flagging off, but maybe others also have some similar plans. They can tell about that.
Anybody wants to comment? So Dr.
Yeah.
Sumit,
yeah, Himanji. So Terry is working with CPCB and MOUFCC to come up with national level estimates of emissions of different air pollutants. We have been working on making or updating or refining emission inventories for last 15 years. And I would say, I mean, it's absolutely correct that there are different groups coming up with their own inventories. They are not dramatically different, but there are some differences, obviously, because of the different activity data used or emission factors used or some methodology differences. Now, I would say, it has to make a start. I think once there is a national level emission database is in place in whatever form, then slowly and steadily different groups across the country can contribute and keep on refining the emission inventory. Emission inventories are never fixed. They are always in the refining mode. And I think there is enough capacity in India now to keep on refining, updating the emission database, which will come probably in some time.
Thank you. I think I have time left just for two more questions, though there are many questions that are coming online. So I'll use my wisdom to select two more questions before we wind up this session. But we'll definitely revert back on the questions that people are posing after the session and can be directly referred to the panelists to whom these questions are meant to be answered from. So one question is coming from Ms. Neha Singh to all the panelists. I think, let's see, 2019 had significant reduction in air pollution all over the country. What could be the possible reason? So anybody can take this question immediately and answer, because I want to take one more question before we end up. Anyone? Any panelist would like to answer this?
Well, should I?
Yeah, please go ahead.
Yeah, so I think, there are a number of things which are happening. LPG penetration is, of course, one of the very important factor which has led to a somewhat reduction in the household air pollution or air emission levels. Slowly and steadily, the older fleet is going away from the overall transport sector, and newer technology, Euro 4, Euro 3 vehicles are on the roads. I think these are the two major things which have resulted in some sort of reduction. Then at the city level also there is some reduction you can see because of the local measures taken. Like in Delhi, you have these peripheral highways which have come. The industries have been asked to shift on gas, and so all this is actually contributing to some small reduction in the concentrations of pollutants. But I must repeat myself that the reductions which we are seeing are directional only, and they are minute, and there is a lot to be done which can sustain these things over a period of time, and more dramatic reductions are required before we stop.
There are two questions. One is from Ashish. It's like water, there are no methods to treat polluted air. Is there any innovative research going on in this direction? The second question is, can plantation remove pollution as compared to lockdown? Anyone who wants to take this question?
I'll take the first one. This is Sharat.
Yeah.
I think the word innovation is very tricky. I think we know exactly what needs to be done in all the sectors. In every sector that you can pick up, there are enough technology examples that are available from all the regions, and a lot of examples available in India as well, which doesn't get replicated. What we need is not innovation. What we need is applying those solutions at scale so that the results are there for clean air.
All right, thank you. So, ladies and gentlemen, the session one has come to an end. I thank all the esteemed panelists and the audience for making the session engaging with their excellent and spot-on presentations. I also want to thank the audience for making the session extremely interactive through their questions. I thank everyone once again, and now pass on the baton to Professor Sagnik Dey for moderating the next session. Thank you once again. Thank you.
Thank you, Hemant sir. Now let us begin with our second session, that is mitigation and policy. And the moderator for this session is Professor Sagnik Dey.
Yeah, thank you, Loveleen. So without much delay, let me welcome 4 panelists for this session, which will focus more on the mitigation and policy aspects of it. And for all the panelists, I will just remind you at the mark of 8 minutes so that you can wind up in the next couple of minutes. So our first panelist is Dr. Santosh Harris, who is a fellow at the Center for Policy Research, and his research interests lie in the area of energy and environmental policy and regulations of air pollution. Over to you, Santosh.
Thank you, Sadnik, and thank you, CERCA, for organizing this discussion. I'll be basing my comments on a recent report that I have authored with Shivani Ghosh, where we attempt to take stock of what the many disruptions caused by the COVID pandemic or caused by the response to the pandemic imply for air quality management in India. Obviously, such an exercise is rife with uncertainties. What we've tried to do is synthesize based on government announcements, academic papers, briefs, and many newspaper articles published over this period to piece this story together. Our analysis reveals that the disruptions are likely to result in 3 sets of outcomes, each offering a different call to action. There are new opportunities to accelerate transitions that are beneficial to environment and health. There are regressive outcomes that are possible in the guise of accelerating economic recovery that need to be firmly contested. And then there are certain avenues for sustaining recent progress. I'll talk about each of these in turn. So the first set of outcomes are opportunities to set a new agenda or provide impetus to ongoing efforts. If and when harnessed, these will allow us to lock in infrastructure that or accelerate behavioral changes that are well aligned with improved air quality outcomes. We're just talking about household sources, for instance. Household sources, that is the use of polluting, typically solid fuels, for cooking, heating, etc., form the single largest source of outdoor PM 2.5 exposure, in addition to the enormous health consequences indoors. So as somebody mentioned earlier, when the lockdown was announced, as part of the relief package, 3 LPG cylinders were provided to Ujjwala beneficiaries in March to be consumed over a period. And this idea of increased targeted LPG subsidies to the poorest households could be sustained as a social protection package. There are still questions, though, on how best to target these, whom to keep within the net. There's a possible risk of restricting ourselves only to the Ujjwala beneficiaries, which is probably counterproductive because there are a larger segment of poor households that will require assistance of some kind. On stubble burning, as we know, this plays an important role in the first spike in pollution levels that we see in the winter in North India in late October, early November. A long-term solution here is transitioning towards more sustainable cropping choices, right? And this year, during the lockdown, uncertainties in labor availability have led to a larger cultivated area for alternatives to paddy. So cotton, maize, basmati. And the government now needs to ensure that these alternatives are truly viable to farmers so that this transition is sustained. To help revive the auto sector, there has been a call for vehicle scrappage policy. This has sort of been imminent over the last couple of years. This demand for vehicle scrappage policy, so incentives to turn in old vehicles, ways to sort of use the scrappage and so on. This demand needs to be channeled towards replacing the oldest, dirtiest commercial vehicles that are currently on the road that contribute disproportionately to air pollution. The Minister of Road Transport and Highways only late last week said that the policy might be announced by the end of this month. Large-scale behavioral changes don't happen easily. And now that many of us who also tend to rely extensively on private vehicles, on cars, for example, have been forced to move to working from home and online meetings, it's important to sustain this to minimize avoidable use of private transport in the future. With the financial sector deepening, with the financial crisis deepening in the power sector and a drop in electricity demand, Incentives are perhaps even better aligned now than before to retire old polluting plants so that newer, cleaner plants can meet a larger fraction of the demand. So perhaps that's an opportunity that can be harnessed as well. In the second set lie the potentially regressive outcomes, which need to be firmly contested. Some of these outcomes arise from government efforts to dilute environmental safeguards, formally or informally, while citing the need for urgent economic recovery and improving the ease of doing business. So the draft EIA notification, of course, looms large in the story and could have massive implications. For those of you who have not been following, the EIA notification dilutes the process to obtain an environmental clearance, reduces the categories of projects and activities that will have to undergo impact assessment scrutiny. It curtails public consultation processes significantly and proposes procedures to deal with violations that are legally untenable. And will effectively allow environmental offenses to be condoned at very little or no cost to the violator. We, perhaps we'll discuss this more shortly. Likewise, there have been unacceptable delays in complying to the power plant emission norms laid down by the MOFCC in 2015. As Center for Science and Environment Analysis recently suggested that 70% of the coal power plant capacity is unlikely to meet the extended deadline of 2022 as well. The current crisis cannot become yet another excuse for delays. Recent reports, in fact, suggest that the Ministry of Power is now recommending a further extension of the deadline by 2 years. This is deeply problematic. The call for increased transparency in monitoring and enforcement data becomes even more important now as a result, as a crucial tool for local communities to hold polluters and regulators more accountable. Finally, those who can afford not to use public transport may now increasingly move towards private vehicle use, right? Due to distancing concerns and so on. It's important to ensure that public funds, especially those earmarked for air quality, are not directed towards infrastructure like flyovers that only tend to lock in private transport. Finally, there are some areas where there have been steady but significant developments in air quality governance over the last couple of years that need to be sustained. One reason, according to me, for cautious optimism here is that the National Clean Air Program and the recently allocated Finance Commission grants linked to air quality have seemingly been unaffected by the fiscal crisis. So the fiscal crisis is real and deep. Obviously, that's something that we need to be very aware of. But it does seem like the air quality linked grants are unaffected as we speak. So there is, of course, a need to continue strengthening processes under the National Clean Air Program, updating the list of non-attainment cities and tracking progress, for example. The city action plans themselves need a lot of work. Many of them are sort of copy-paste versions of each other. It's important to sort of get on with the work of identifying and implementing policy priorities in each of these cities and updating the knowledge base in parallel. These have to be parallel activities.
Just 1 more minute.
Yeah, thanks. So last year, the NCAP progress was hobbled by its modest budget. This year, the 15th Finance Commission grants to 42 large 1 million plus population cities for 2020-21 are an order of magnitude higher. So it's rupees 4,400 crores for this year. However, there's a new channel for funds. Even as we speak, we don't yet have the formal performance framework being notified by the Minister of Environment, Forest and Climate Change. So much depends on this performance framework that needs to be finalized soon, and on how the state and local governments use these funds. They need to engage with civil society much more than they have so far with the National Clean Air Program. And of course, the grants cannot be only for this year, they need to be sustained over a much longer time period. Now, to truly see improvements in air quality levels and effectively allocate resources, both NCAP and the FC grants process needs to move towards airshed management, which also has been spoken of earlier. In an encouraging sign, the Environment Minister also indicated that this is a priority for the ministry. And for the researchers in this community, therefore, we need to develop ideas on how precisely they should be operationalized. So the COVID-19 pandemic has appropriately brought about an urgent response given the scale of its effects. And yes, dealing with the pandemic and getting the economy back on track are crucial. But as we set in motion recovery plans, we must not forget that air pollution, that arguably has a long-term mortality and morbidity burden that is greater than COVID-19 is so far, touch wood. We must not forget that, we must ensure that air pollution too is tackled with a proportionate sense of urgency. With that, I'd like to conclude. Thanks.
Yeah, thank you, Santosh, for a very comprehensive overview of the opportunities in this era. Our next panelist, I will take the questions at the end. Our next panelist is Karthik Ganeshan. So he's an engineer by training, and Karthik leads the Council on Energy, Environment and Water, CEW's work on the clean energy and environment. So I invite Karthik.
Can you see my screen?
Yes, sir.
Yes. Yeah.
Okay, great. Thank you. Thank you, Sagnik and the organizers of the webinar to have me speak here. So my presentation will perhaps be the one that is not really going to speak much about air pollution itself, because we've heard about it from so many of our speakers so far. I'm going to touch upon the concept of citizen science and what can make citizen science count. I'm a research fellow at CEW. We're a not-for-profit policy research organization based here in New Delhi. So what is citizen science? So citizen science is basically scientific research that is conducted in whole or in part by amateur and non-professional scientists. So a lot of the people who are actually stakeholders in the space of air pollution, the civil society organizations, the research, aren't actually full-time researchers. Right? They're people who are trying to actually mobilize opinion, on air pollution and try to get authorities to actually act on it. So it's very important that we take into account what is it that people need. So what exactly does citizen science do differently? So citizen science, the basic pillar of this is that science should be responsive to the needs of citizens, their concerns. It should not be something where we're just carrying out research on understanding, a particular topic for the sake of it. It must also enable citizens themselves to produce reliable scientific knowledge, right? And that is one of the fundamental pillars as well. And the most important thing about citizen science is get more people interested in a cause by providing them adequate information and giving them a sense of community that, this is an issue that is shared by more people around you, and they will help you sort of further your own ideals. Do people recognize this particular image here? I think there's a giveaway there on the screen. As you can see, this is the impact site of Vikram lander on the moon. When the landing did not go well. And as you know, the images of this particular landing site was actually released by NASA. And what actually happened was that an Indian techie who happened to sort of really sift through some of these images, discovered where the impact site actually was, and suggested to NASA that, hey, this is probably what you're looking for, because he actually found debris or images that suggested that debris was here. So this obviously required resources that was even beyond the capabilities of NASA, because somebody had to actually go through with a fine-tooth comb what was actually there on the surface of the moon. You may have heard of many of these initiatives. So you've got this website by the name Zooniverse, eBird, and iNaturalist. So these are three of the most popular citizen science initiatives across the world. Some of them have millions of people on them. So as you know, Zooniverse is basically like a open source initiative to help you create projects to understand problems of any scale. One of the biggest projects is called Galaxy Zoo. I'll talk about it in the next one. Bird is a platform that I'm personally very interested in. I'm a contributor to. Basically, as amateur birders, we contribute information regarding, location, sightings of birds to enable actually people to understand where are these birds located, what is their pattern of migration, so that other people can go pursue them. And other people, I say that it's not just a rabbit citizen, but even scientists use that. And iNaturalist, of course, is the first of its kind, which looks at the entire natural world in its, and then scheme of it. So how do sites like this work? This, for instance, is an illustration from iNaturalist, right? So you recorded observations. You share that with fellow naturalists, and of course, it is available to the wider public. And then you discuss your findings. Simple as that, right? And of course, with the mobile phone becoming so ubiquitous, our ability to collect information regarding our surroundings is almost, unlimited, right? And the capacity to share information and data and everything being available. Now, nature is basically at your fingertips. So what are the basic steps that are involved? You keep track. right? You create useful data. So there are these apps that have been made by the initial groups that have created this. You crowdsource identifications. You basically put up the information out there and somebody asks somebody, hey, what was it that I saw, right? An expert might respond to that, may even be a lay citizen as well, right? And then you basically end up learning about nature. And then, of course, you can create your own content as a result of it and further promote the interest in the topic itself. So this is really the fundamental pillars of citizen science. So, do that many people actually participate in citizen science? Well, if statistics are anything to go by, Galaxy Zoo, for instance, right? They basically help identify galaxies that are yet to be discovered. Can you imagine that? That is how interesting it is. So their tagline is, you may be the first person to actually do this in the world. So there are 52,000 volunteers who are actually looking at galaxies that have not been spotted by anybody so far. So they're basically trawling through millions of images that have been put up there by the likes of the Hubble Space Telescope and all the other satellites that have gone through, right? Gone up, and the spaceships, right? And you know, as many as 234,000 subjects have been identified, or at least out there for identification. And 1.8 million classifications have happened. Similarly, when it comes to iNaturalist, look at the number of species that have been observed and the number of people who signed up. So 3 million people. Of course, all of these topics are of interest to the average person because they give you a lot of pleasure. They give you mental stimulation, and as a result, people engage in them. So how can we sort of leverage this for air pollution? The beauty is, or rather the sad part is that air pollution is everywhere, right? The sources of air pollution abound us. They're continuously surrounding us, which means that they're always, in the thick of things. Citizen science and air pollution really are a match made in heaven. Because, pollution information and provision and monitoring is right now centralized. It means, it's the Central Pollution Control Board's duty to put up monitors and they send data that comes across to everybody. But the reality is that we all live in places where the sources of pollution are very much local. We're not aware of what's actually harming us. And at the end of the day, we must each be sort of like an eye out there, right? An eyepiece or a mouthpiece, right? To sort of comment on what the state of air pollution around us is. And unless we actually get to that point, it's very unlikely that air pollution at every corner of the country will be captured and the needs of all these diverse groups will be captured. Because right now the discussion is entirely city-centric. We don't even know what's happening in rural areas. So what we decided to do was, take our focus on central UP, which is, one of the most polluted areas of the country, as well as the most populous. And we tried to sort of run a small survey, a representative survey across, central UP to find out what is the awareness level that people have around air quality. 90% of households believe that the air quality in the area is pretty clean, despite the fact that it's probably twice or thrice the national ambient air quality standards. And UP has the largest deaths when it comes to air pollution related deaths. If you look at it, education level plays a very, very important part in people understanding whether air quality, the air quality is good or bad and what the impacts are. So obviously, much of our country has attained only primary education, and much of the people who have attained only primary education do not have a very good sense of what is the impacts of air quality or even what the quality of air generally is. Right? So between urban and rural, there's a very, very big divide. People could not even perceive. We talked about, so many questions came up about the lockdown having an impact. Sitting in cities, we all immediately saw it. But sitting in rural areas, despite the fact that they're quite polluted throughout the year, most of the rural respondents actually said that they did not see a perceptible change in air quality, right? Which is quite startling, given that, so many questions around continued use of biomass in households would have already been there. So is it that, they actually did not sense it because, they continue to stay in polluted environments, or was it that the sources of pollution around them did not change? Either way, this is a situation that requires correction. And unless we actually have eyes and ears on the ground telling us about what the change is, it's very difficult for us to assess it. We have to bridge the gap. Regarding the sources of pollution, right? Unless you're actually constantly observing what's around you, it's very difficult for us to say what is polluting us. The big question, the discussion that happened here was how many people think that burning of solid fuels inside the house is a big source of pollution? Less than 10%. But in rural areas, that is the biggest contributor to local, indoor as well as ambient air pollution. So we have to bridge this gap, and for this, people have to sort of start looking at their surroundings more critically, examine what the day-to-day changes are. Of course, looking at nature and looking at galaxies far away might seem sexy or interesting, but the fact is this is much more closely tied with our well-being on a regular basis, and we have to give it that kind of mind space to be able to achieve the outcomes. And
I'll take 2 more minutes.
Yeah, and essentially it's good. It's very, very important to have metrics that actually convey the severity of air quality. Unfortunately, what is happening is that the AQI, which is designated in 2014 as the means of communicating to this, does not speak to most of the citizens of the country. Very few people actually are aware of what the AQI actually does. and what it actually corresponds to. So we've not really done well when it comes to communicating air quality. And unless we get people to start thinking about air quality in a different way, we can't do much. So what is the real ask? We're saying that we must change the perception around air quality and the importance of clean air. Making public air pollution monitoring must be ubiquitous. Right now, you've got 200 monitors around the country, which do not satisfy the needs of every aspect of the every group in the country. It is not just about citizen sensing. It is not about citizens hosting low-cost monitors in their household. Because as much as that is sort of like the easy way to go about it, it's very expensive because not everybody can afford it or be part of a project where you're monitoring local air quality. But what you can do is actually can you communicate the catastrophe that air quality has become, right? And for that, we need to do this. Who will see this idea? This will actually have to happen from private initiative. It can't be the government that's doing this for you, because it's not really in the government's interest to make its citizens more aware of how bad the air quality is. Unfortunately, that's the reality. Right? Encouraging more people to take cognizance of the air that they breathe can really help. And for this, we need to sort of have initiatives where we periodically provide inputs on air quality. We do this regularly, for instance, with communities in Pune, which has a very ardent, outdoor community, which sort of likes to go outdoors and very cognizant of the fact that they're breathing bad quality air. We see that when you actually empower such communities with information, they come back to you asking for solutions. Right, and this is a community that generates about $4 billion in revenue every year, right? In this particular one in the IT hub of Pune. And finally, small networks that respond to local needs. And ultimately, this starts at homes, RWA, schools, universities, actually getting them interested. And this is primarily going to start by providing regular data and insights, and then getting people to slowly move up the ladder to say, what, can you also provide us inputs periodically? And the mobile phone, as I said, is the most ubiquitous device, at least around urban India. So can we get inputs from them as well? And it is really in our hands and how passionate we are in examining the air more closely that is around us. I leave it at that. And finally, I have a quick 2-minute video, Sadhni, if you allow me to play it. It's very beautiful. This is really not about air quality, but really about this, I think, the most successful forum that's been created out there to understand what citizen science can do. Let's quickly hear from the eBird community.
Every day, millions of people around the world enjoy watching birds and recording their sightings. What if there were a way to take all of these observations, yours, ours, everyone's, and put them all in one place?
If we could do this, we would fundamentally transform not just birding, but science and conservation.
From this idea emerged eBird. Put simply, eBird is a way for anyone around the world to store their birding observations, their photos, their sound recordings, and make them available to educators, scientists, and birders. It's incredibly easy to use, and it's incredibly powerful. All you do is let us know where you went birding, when, how far you traveled, and what you saw. It's powerful because hundreds of thousands of people all around the world are doing it, and it's growing. eBird already safeguards 500 million sightings, information that allows all of us to understand the movements and needs of birds at global scales. eBird maintains your lists for you and shares them with other birders from around the world. By sharing, it's now possible for anyone, anywhere, to find your target birds and the best birding hotspots any time of the year. Before eBird, there was no way to comprehensively understand population-level movements of many species. By combining your sightings with remote-sensed habitat data from NASA, we're able to generate species distribution models that provide an unparalleled view of where and when birds are in the landscape. Scientists...
I'll just pause there. So replace, birds with air pollution, and every one of the concepts that is there in this applies to the study of air pollution itself. And this is ultimately, the kind of initiative that we're trying to work with IIT Delhi as well. And we're part of a citizen science initiative that is actually funded by NASA, where we're deploying about 100 monitors across the Indo-Gangetic Plain. And we hope to sort of, start in a very small way by engaging more citizens in understanding what the air quality is around their homes and where they live, and improving the quality of debate that's actually happening around air quality itself. I think the link to this has been shared in the comments. I'll leave. Thank you so much for your time. Sure. Thank you.
Yeah, thanks, Karthik, for making this important highlighting the importance of taking citizens on board in this battle. Our next panelist is Dr. Anumita Raichaudhuri, who is Executive Director for Research and Advocacy and Head of the Air Pollution Program at Center for Science and Environment. Over to you, Anumita.
Thank you so much. So what I'll do, I'll not show slides, but just make overall observations based on essentially what are the key roadblocks that we are noticing and observing now from the perspective of implementation of clean air action plans in different cities under NCAP. So as we know, and we have all discussed already, that the CAP implementation has begun. And this whole implementation is happening to meet the NCAP target, which is 20 to 30% reduction by 2024. And also the Finance Commission's target, which is also 5% annual reduction. Now, from that perspective, the questions that we all have. So are their plans effective? Are cities on track? Can we ensure time-bound compliance across all sectors as they are multi-sector plans? And within that context, the narrative, which has certainly gained a lot of credence and credibility and importance, is what everyone is talking about today, our idea of prioritization. That whether that is the way that we prioritize action in cities to be able to show effective impact over time. Now let's therefore build this conversation around that and see that how do we understand prioritization in relation to the key drivers of action, which is science that all of you have discussed just now, and the science which is expected to bring more precision, accuracy, interconnectedness of factors to inform action. And then the other area, which is about the legal compliance, monitoring framework, and institutional capacity. And then the third driver, which is the investment driver, the money, the funding. And then the other driver, which is community demand for clean air, so that we can change the politics around the narrative. Now, quarterly reporting has started. Cities are already submitting their progress report to CPCB, and they're also beginning to get their feedback from CPCB and the monitoring committee. So let us understand from the city's perspective, because now as we are also working a lot more closely with the state governments, and there is a certain amount of reality check that has become possible. So let's understand according to these drivers. So first, and we have just heard fantastic presentations from all of you, the scientist community, and we know that NCAP, which is a good step forward, has created the mandate for science-based air quality management. And therefore, today, the NCAP is asking for better monitoring. They are investing more in air quality monitoring for data, higher level of analytics, pollution source profiling, pollution forecasting, and all of that we believe should happen. But again, the question is about scale and replicability across the regions. But when we are looking at it from the city's perspective, what we feel that while all this is happening, monitoring is expanding, it's very important to pay attention to also the grid design, the monitoring grid design and quality control of data. And there is no conscious conversation on this as yet. And also the grid design for exposure mapping, because a lot of science is telling us and has convinced us about that. And therefore, so the exposure mapping, whether the grid is adequately designed for mapping of the sensitive population or not. And the question is, for that, we don't need any deep legal reform, because if you look at the current CPCB guidelines for monitoring, you will find that it already provides for sampling intake at 3-meter height above the street level. It asks for residential pedestrian exposure, neighborhood exposure stations. It's all there, but it's not informing the current practice. So that's one area we need to look at. And also the very important points that have already been made about the airshed approach, regional approach, and use of alternative method like satellite. The question is, how quickly can we get the operative framework for that? We know that the Air Act already provides for critically polluted area. Can we apply that concept to design a regional plan quickly? That's another area that we need to look at for it to be effective. But the much bigger roadblock that we are noticing is regarding the science of designing solutions for prioritization. Keep in mind that most plans that have been made, even the baseline assessment of action has not been carried out to understand the gap identification based on what should be the critical guiding principles to reach the target. Now, if that does not happen, that means we don't even know how to design the action adequately. And therefore, it's very important to understand that why weak program or a weak program design makes prioritization meaningless and compliance ineffective. So action plans, as you know, should be adequately defined with clear indicators on the technology intervention, infrastructure design, service level improvement, fiscal strategy as applicable with strong outcome level points. But when you look at most of the plans today, they're oversimplistic. So take for example, industry. Now in industry, in many cities that we have seen, the plans just say, monitor industrial pollution, supply clean fuel, action against defaulters. Now the question is, this is something that the state pollution control boards do, that's their function. Now why we're only doing that to improve air quality? Now therefore we need to identify the specific strategies there. Now, have we a strategy for the big industry, the small industry? Now imagine, just take an example, that suppose SPCPs have been able to ensure compliance in small scale industry, say with regard to the boilers. I mean, it's not going to make any difference because the boiler standards are so weak. Even if they comply, it means nothing. So that's where you need to define the role of the central government in dealing with the standards. But the state governments can look at some more specific progressive steps. Can we have common boilers and therefore design a program around that? How can clean fuel strategy happen? And they're talking about it. The UP plans are talking about bringing natural gas to industrial estate. But can we do this if we do not address the pricing of clean fuel? So these are the critical points that if we do not address, then we will not be able to get there and need more precision when we are saying that we are going to monitor progress. For instance, with regard to the power plant, do we have plant-wise progress to be reported? Another critical roadblock is that the danger of combining weak program design with strong compliance. And suppose, for instance, if the program itself is poor, and this comes out very clearly in the transportation sector. So all plans are talking about improving public transport, have more buses, metro, cycle track, and walking track. But without indicating the scale and service level improvement required, because that doesn't demand the science for that planning. It does not demand for data on trip generation, on average travel distance, on modal share. So if you do not know the boundaries of that, then how will just providing some buses here and there and a metro line there is going to make a difference? Secondly, when you are saying, the plans are saying that you also need wide roads, flyovers, and multi-level car parks. Now imagine, NGT has a very powerful instrument today of compliance where they put hefty fine on the governments. Now, if Chief Security Committee is therefore says, okay, fine, the plan has promised so many multi-level parking, then they will just go on an overdrive to make those multi-level car parks. Now, this is wrong, and we are going to get a wrong solution. But here what is happening is some cities have done better, where they are giving more detailed indicators for the solution. Take for parking, for instance, where some state governments have actually said how that should happen, not just multi-level parking. They're saying we need area management, pricing, all of that. But in their case, they are also getting mixed signals from the monitoring, because then all the elements that they have to include for implementation gets interpreted as too many elements in the action plan and therefore no prioritization. Now, therefore, if we do not understand that what is required from the solution and give a wrong feedback to the city, that means you will end up, cities who might be doing a better job will be restrained from doing it. So we have to be very careful about these things.
I'm wait 2 more minutes.
Yes, okay. So, and here, therefore, this is happening because the Clean Air Action Plans are not aligned with the larger sectoral policies. Like, for instance, in the transport sector, any sectoral plan for transport should align with the transit-oriented development policy, national urban transport policy, and design the indicators based on that. So, similarly with the industries, as we have said, And then so program design requires a lot of attention for prioritization. That I just want to say. The last couple of points that that cities are actually doing more than what they require to do. But this is not getting leveraged to the cleaner action plan process. Very evident in the waste sector. So if you look at the cleaner action plans, you will find that the waste sector caps are saying that stop burning of garbage and you'll be penalized. And in construction, they are saying just do covering and do sprinkling. These are the action points. But they are not saying that the action has to align with all the central rules and regulations with regard to waste. And here the states are actually doing more because there is a Sarvekshan Swachh Abhiyan program, there is Amrut, there is Smart City, and whatever change that is happening there with regard to segregation, recycling strategies, uptake of the market of the reused thing, these are not coming into the reporting of NCAP. And therefore, the budgetary alignment that should happen across sectors aligned with the cleaner goals is not happening. We are not optimizing the investments. And the final point, the 2 points that I just want to highlight, that NCAP monitoring has to identify clearly that what is the state role and what is the central role, and both will have to be tracked together. And this means that all state, if standard has to be improved, if policy guidelines have to be given, if fiscal strategy has to come, if indicators for common strategies across all states, because BS6 readiness, PUC, dealing with old vehicles, they don't change according to geography and climate. You need certain standardized strategies. So all this handholding, so therefore central role will also has to be established very clearly in the reporting. And my final point is that while we are talking about the, the compliance monitoring, we are saying that you have to be careful about that we need, yes, compliance, and this, we need to look into the legal reforms. We need to look at the institutional capacity. For that, just not the SPCB's institutional capacity, but capacity audit across all implementing agencies and departments that will have to be carried out. And the compliance and legal reforms are not just related to Environment Protection Act or AIR Act. It is also sectoral policies and legislations that will have to be well understood. And my last point here is that right now, when we are in a COVID situation, it's a very strange situation for us right now. The biggest challenge is that how do we maintain level of ambition during this pandemic when there is such an economic slowdown? So at one level, air has cleaned up by default, but at the same time, the baseline ability of the states to do system improvement for implementation is far poorer and weaker and today. Now, therefore, how do we create a good central level policy where you ensure, and NCAP has to give that signal to the central government policy that can we have a green recovery? Can NCAP be designed for green recovery? Because if we do not do that, you will not have the investment drivers to inform the strategies. And so imagine when everything has collapsed, why will industry meet new standards? Why public transport will improve? Because you should look at their economic performance at the moment. That's a huge pushback there. So if NCAP does not come up with a nimble solution, well-defined criteria to how to address the current crisis, link it with recovery, then the roadblock to implementation is going to become much harder going forward. Thank you.
Yeah, thanks, Anamita, for highlighting the important roadblocks and showing some directions. And I hope that in this Delhi City Knowledge Network Cluster program, we will be able to at least address a few of them. So next we move to Dr. Harshal Salve from AIMS New Delhi, who is a physician, public health professional, and has a vast experience in air pollution epidemiology. He will talk about how to integrate the health outcomes in air pollution policy, mitigation policy. Over to you, Harshal. Harshal, you are not audible.
Harshal, sir, you're on mute. Dr. Harshal? You're on mute, sir.
Harshal, you are on mute.
Audible. It's audible.
Am I audible now?
Yes, sir. Yes, sir. It's
audible.
audible.
So sorry for the technical glitch.
So again, thank you, Sagnik and organizers from CERCA for having me here on this important webinar on an important day for all of us. Till now, we have heard from exposure scientists, the social scientists, and from the social activists on basically on implementation issues for mitigation related measures, the exposure measurement issues. So I work on the health outcome side, obviously by my training and by my practice. So I will briefly discuss about what are the health outcomes which are available. And I've been informed that most of the participants are the researchers, the students, the fellows, the research fellows. So I thought it will be interesting to talk regarding how to do research with respect to air pollution and how to communicate the research to the policymakers and to the communities. So I think all of us are well aware of the outcomes of the air pollution. So it affects from top to bottom of the human body. So and various air pollutant affects various organs. So and with the evolving science over the period of time, we have seen newer our health outcomes which are being sort of been documented. Initially, it was restricted to respiratory system. Now the neurological system, the cognition, the development in early childhood have also been reported as outcome of poor air quality, as well as the generational. It also has an impact on the life cycle approach when we say, which is starting from the pregnancy to the newborn. So it has a larger impact with respect to the various health outcomes. So as I said, the strong evidences are always there for CVD strokes. The emerging evidences are been reported with respect to the mental illness like depression, suicide, cognitive impairments. So, which are the health outcomes to prioritize? As a researcher, we need to work on the low-hanging fruits, which are more to focus on our research, which are high burden, which are the diseases which are more contributing to more disability at just life years. All of you are aware of the global burden of disease, where it talks about the daily is contributed to the various disease, the cardiovascular diseases, the respiratory diseases, and the mental illness, for example, depression. It contributes larger to the overall diseases. So our focus should be on dealing with these diseases because that will garner more attention with respect to the air pollution research. The diseases which are easily measurable, it doesn't require too much laboratory setup, which can be easily measurable with the help of some self-explanatory questionnaires and some basic laboratory measures, the preventable morbidity and the mortality. So this is more important. Whenever we talk about linkages with the morbidity and mortality, we always focus on what are the preventable things, preventable both mortality and morbidity thing with respect to air pollution research. More important area is work on the vulnerable populations, for example, pregnant women, newborn, children, elderly. So our research should focus on these vulnerable population because these are the population which gets affected more, and the outcome of the intervention will be more. So the cost effectiveness of the intervention will be more. It will be easy to convince the policymakers, the funders for the research, and the policymakers for the possible interventions. Coming to the various sources of the data in India, so we know there is a morbidity data, which is the disease surveillance data set, the IDSP, cancer, we have cancer registries, we have other disease registry, for example, stroke registries, CVD registries, the registry related to the myocardial infarctions, which is there. The national surveys now they are focusing on the morbidities, for example, National Family Health Survey. We recently had a third round and the fourth round, the fifth round, fourth round and fifth round is in the process of the result being taken out. The National NCD Monitoring Survey, which as we did it for ICMR and the ministry with respect to the NCDs and the various prevalence and the burden. So these surveys and these data sets provide vital information with respect to morbidity. So that can be used into the researchers, the research, and the linkages can be shown. Coming to the mortality, again, the most important factor, and we all know, and the deficiency of data with respect to the mortality in India. So, because of the poor civil registration system we have, which covers only 70% of the deaths. But we have a sample registration system, we popularly known as SRS. Now, as our institute in our department, we are doing it as a form of Minerva mortality surveillance with the help of verbal autopsy, we call it as. So where the cause of death ascertainment is done. So we know the deaths happening by the what cause. So this we call it as a cause-specific mortality. So it is important to link exposure data with this cause-specific mortality. So, and where in India we have almost 33 SDSS site, health and demographic surveillance site, which continuously monitors. One of the site is at our setup in AIMS in Ballavgarh district, Faridabad, where we are monitoring almost 100,000 population for their vital status, for their disease morbidity. So these provide a very vital information with respect to the prospective data. So you can actually analyze the impact of air pollutants on life scale with respect to the from birth to the adulthood or birth to the death by using such data set. There are many cohort studies which are going on across India. Few are named here. So the integration of these cohort data set to look at various diverse health outcomes and linkages with the health exposure. Few of the studies are already doing it, but linkages can be a beneficial to have a comprehensive assessment of impact of air pollution on the health outcomes. So briefly about the Minerva, as I said, is the mortality in India established to verbal autopsies. So SRS sample system covers 9,000 representative samples. Currently, this office is hosted at us. This is funded by Registrar General of India, by the Ministry of Home Affairs. So we have 23 network partners and almost more than 250 doctors are coding the deaths on daily basis. Formally, it was known as million death study. So this is an important data set of cause specific mortality we have, which can be utilized for generating evidence linking the cause specific mortality with the air quality exposures. And there are major challenges in linkage of exposure, particularly
Two
air
more minutes,
quality and the health outcome data. Yes, outcome assessment, non-specific health outcomes are there because most of the outcomes are multi-exposure related nowadays. It is not an agent and the disease outcome like infectious disease. The non-communicable diseases are mostly multifactorial. The exposure assessment is challenging because most of the exposure assessment we have at the population level, whereas the health data we have at the individual level. So personalized, though it has started a personalized exposure assessment, but it is a costly, there is a calibration issue, so that remains a challenge. The source and the characteristic of particulate matter, the health risk, the composition of the particulate matter remains a challenge, and the dose response relationship. So we can have a very hyperbolic, the air quality exposures, and most of the environmental exposure has a hyperbolic relationship with the health outcomes. So it's very difficult to measure the impact on the various, the larger population level. And it is also important as a form of advocacy because uh, to see the tangible impact on the health outcomes, you need to reduce the air quality, improve the air quality by a larger extent. So the smaller here and there change in air quality will not help in having some visible impact. Access and suitability, vulnerability is mostly missing. That should be part of the research. And local research and the data is critical. We have a national level surveys, but to generate a local evidences for linking air quality and the health data is critical. There is something called as accountability research. I think the previous presenter already mentioned about various regulatory mechanisms we have. So the researchers have an opportunity to do some accountability research with respect to the various regulatory actions, emission related actions, ambient air quality related actions. Various interventions government has come up, for example, the SUFFER app, the CPCB app in terms of usability, in terms of its impact on the health outcome. So this is the scope of accountability research for the young researchers. They can take up the impact of stubble burning, prohibition. There is a PMYU, Ujjwala Yojana. Recently, the lockdown. The lockdown has impacts in terms of reducing ambient, improving ambient air quality. But the limited studies are available with respect to the improvement. What is the status of indoor air quality, and more so, what is the impact on the health? Then the brick-clean exposures, personal product to measure effectiveness, ban on firecrackers, which are introduced last year. So these are provides a scope for accountability researchers. Coming to the communicating the research and finding, this is very critical and important step for the research. We have various modes of research communication: the scientific paper, conferences, workshop, training programs, the policy briefs. where we document to synthesize the evidence and concise it present to the government, and IEC communication to general public. What we have found, because we work in the community, most of the IEC created, and we have just heard that people are not aware about the air quality. They are not sensitive to the worsening air quality. This is because we are not communicating in the research in the manner it has to be communicated to the population, and in a manner it has to be communicated to the policymakers. So there are 7 C's of communication, we all know. So we have to customize our research findings with respect to our audience. That is very critical to generate some sort of, because behavior change communication on both sides, on the policymakers to prioritize the air pollution research, as well as on the community, is the critical, without which we're not going to achieve anything, whatever we can do. And this is the most of the time people ask this question: where is the evidence affect the air pollution? Where are the people dying? Show me. We can know the person dying because of the accident, but we can show them a person dying because of air pollution. So that's why we have to customize our product in the form of research communication with respect to our audience, advocacy for this thing. What policymaker wants, because there is also some sort of inertia with respect to the interventions from the policymakers as far as the air quality, air pollution related health effects are concerned. So we need to quantify, because they understand 2 things, policymakers. One is the life save,
if you can
and second
finish
is the
in next
economic.
1 minute.
Yeah, so economic impact of any interventions and prioritizing on their priorities of the health policymakers. For example, maternal and child health is a priority of the policymakers over the years. So we need to build our case of air pollution and the health impact on these lines. What are the economics related to it? How the interventions are affecting the population? How the interventions can affect the livelihood? What is the economic fallback? What are the livelihood implications? So that has to be built in when you make a policy brief. Just to finish it up, this is our joint collaboration we are doing with the SAGNIC as a part of AIMS IT joint collaboration, where we are trying to generate a more local data set with respect to the mortality, more specifically the cost-specific mortality, which is lacking at a larger level with the PM 2.5 exposure. Sooner we are going to see the result of this study. Thank you so much.
Yeah, thanks, Arshal, for a very nice overview of the health impacts and the requirements. Since we have already exceeded the time, we'll restrict the question and answer session to 5 minutes. So if we can start the questions which are asked. So first question may be directed to Harish. Is there any lockdown impact seen for the open burning practice?
Thanks. It's hard to say. So when we say open burning, for example, there were episodes of stubble burning, for example, in May. When it comes to waste burning, this is actually quite hard to track. And therefore, I suspect that, so I mean, just in terms of like the causal factors, I can only imagine that constraints on the waste management capacity would have only increased waste burning as opposed to reducing it, but this is just a hypothesis.
Sure. Yeah. So there's a question for Karthik. So Karthik, one of the major concerns often shown by the ministry, that when you sort of give citizens, when you empower citizens basically to come up their own measurements using low-cost sensors and all, and then you put out all this data open, there is a chance of misusing this data. So how do you address that concern?
I mean, first thing is, I don't understand what is this misuse of data. I mean, I think being asked to be accountable cannot be construed as misuse of data. I mean, what we've basically seen is, of course, pollution control boards across the country, whether it's CPCB or the state pollution control boards, they're understaffed, right? I've had this really lengthy conversation with the SPCB staff at DPCC when I complained about waste burning in my area, much before. And I remember, the gentleman basically got put up to the point where he's like, I cannot do anything about it, right? I don't have the capacity to address this. This is supposed to go to SDMC, so please take it with them. So the problem is that if hundreds of people, forget thousands, right? Hundreds of people basically decide to go to the pollution control boards and complain through the use of the current apps, Samir or any one of them, right? Yep. They don't have the ability to service the demand of each one of these people. So I think that is one of the reasons why you're dissuading people from, by saying that, oh, these are not legitimate. So I think the only way to address this is by having a forum where these can be compiled in a way and augmenting the capacity of the pollution control boards and allied agencies, like, to address the issue of air pollution. If they can't do that, I think they'll always basically say that these are unreliable, this is an untested technology. The entire state of California right now, I mean, especially the Bay Area, as you know, has close to about, I think, 2,000 purple air devices, right? So during this intense fire that California witnessed, right, it was basically these devices that was giving people a lot more insights than regulatory monitors on what was actually happening in their neighborhood for them to take precautionary measures. So I think people should resort to the use of this, irrespective of whether they end up complaining or not. To get, a corrective action, I think you need to ensure that there is a critical mass that's approaching the pollution control board, not on an individual basis.
Yeah.
Thank you.
Yeah, thanks. So next question is for Anumita. So Anumita, in the current framework, what we have seen is that there are penalty for not complying to the emission norms and stuff like that, and we have experienced that this does not often work. So isn't it better to really think of incentivizing those who are complying rather than forcing some penalty, and especially in the context of open burning, there is a whole debate going on.
Absolutely. I agree with you, Sadnik, and that's something that we are thinking about a lot, that you do need a combination of incentives and deterrence. And currently, the way deterrence works within our legal framework, it criminalizes the act of violating standards, and that does not go very far. And therefore, we need more systemic solution where the carrot and the stick will work in a way that you incentivize the process to improve as well. And in that, I'll give you one example. Like very recently, our own assessment shows that 70% of the power plants are not in a position to meet the standards by 2022, right? Now, you can sit there with a stick, penalize them, but if you don't help them to find the solution, because we know that given the DISCOM issues, the whole reform that is needed, bankability projects so low, you have to find solutions. So therefore, can you incentivize, and we are calling it a first run policy, where the plants who will be able to meet the standard in advance get the priority in electricity purchase and procurement. So that's the way we need to get a lot more out of the box and innovative to incentivize the process. And only command and control is not going to help us.
Yeah, thanks, Anumita. So the question to Harshal, and I took liberty as a moderator, is that we have this standard, air pollution standards created for India, as well as these various AQI ranges linked to various health outcomes. But as far as my knowledge is concerned, I don't think these health studies are actually from India. So what's your opinion that how we should better integrate the health studies which are being done in India and further refining these AQI levels or the standards?
Thanks, Agnik. I think you are absolutely right while pointing out this concern. So as I said, most of the studies are, because if you really want to map up the studies, they are happening in the southern part of India. And there was a discussion going on in WHO also with respect to whatever the estimate they gave with respect to the premature mortality. So they are in the sort of stage of revising it. It's all a model-based sort of estimates. So in model, what goes in comes out. So the output of the model depends on what sort of inputs you're giving into the model. The data for WHO is again coming from various localized studies. So I think it's a good opportunity for all of us to work together to have a combined either form of network. We are in the process of developing that network to combine these researches and to generate evidence which are more localized, which are more Indianized, and then suggest what is happening with respect to the air quality and the linkages with the outcome. And take few outcomes which are more, not entire set of outcomes we are interested. Few outcomes which are a priority of the government, which are the priority of the current health program, as I said, the MCH, maternal and child health related outcomes, the non-communicable disease outcomes, which has a long-term impact. And as I said, there are high burden outcomes also. So this is an opportunity is there, and I hope this network will help us to generate that evidence.
Yeah. Yeah, thanks, Arshad. So the last question, in the interest of time, any panelist can take this. How can we establish reliability of any data related to air pollution, emission, measurement, anything from multiple sources, as there are no standard guidelines for accuracy?
Can I just take a shot at this, Sagni?
Sure.
Yeah, I responded in the chat window. So I mean, I think there is no clear way of saying X is right. Primarily because even with the regulatory monitors, there is some sort of suspicion as to whether the maintenance of some of these devices is the best possible. But what I think was important is we consume all the information that is potentially available out there. So let's take a look at this the smart cities project that's currently underway. Pretty much every city has 20, 30 devices, small cities, that have been deployed that gives you data about local areas and air pollution that actually is coming out of there. But the problem is we're not even looking at all of that data. Right? We're only looking at the regulatory monitors. We don't even have a sense of how that is. It is very possible that some of these local sources are captured in these monitors. And the idea then for us should be, how do you triangulate that with the activity levels that are likely happening around those monitors? Then say, right, okay, this is the reason why I'm able to explain the higher levels. I mean, but at the end of the day, people who are installing these monitors aren't just doing it for kicks, right? They're doing it because there is a technology that's been established, and the scientists that are deploying them have taken due process. So I think questioning them, unfairly, right, basically puts undue burden on the scientist part as well to say, what, to prove that this is right. Because there's no amount of proof that can actually be shown that this monitor is actually working nice and fine. You can show them scientific processes, but you can always discount them saying this is not the true core product. So let's first consider all of the data. I think a lot of that needs to be done before I think we get to the point where we start questioning this data en masse.
Yeah, thanks. In the interest of time, I want to conclude this question answer session. So there are multiple requests from the audience for the presentation. So we will seek permission from all the presenters and share the link in CERCA website from where you can actually get all these resources. And then I hand it over to Lovely.
Thank you, Sagnik sir. Now I would like to request Professor Sagnik Dey to kindly conclude the webinar with a vote of thanks.
Yeah, thank you. So on behalf of CERCA, it's my pleasure to give the vote of thanks. First of all, I want to thank Mr. Arun Duggal, founder of CERCA, for sparing his valuable time and giving the welcome address. And I sincerely thank all the panelists who immediately agreed to our request to be part of this webinar and provided valuable recommendations and guidance on how to realize India's clean air goals. And I believe that with the collaborative effort, we surely will be able to achieve this. In fact, all of us still are here exceeding the allotted time, and I'm really thrilled by the enthusiasm of all participants in this webinar. I thank all the attendees who keenly listened to the speakers, posed interesting questions, and took part in this webinar. And last but not the least, I thank the Eco India for partnering with CERCA, for providing this platform for hosting this webinar, and the entire CERCA team for making this webinar possible. Thank you all. We'll keep in touch and work together, fight together, and remove air pollution. Thank you all, and stay safe.